check, check, check. Mother Nature has once again smiled on us here in North Alabama as we're greeted by another beautiful morning here in Tony, Alabama, which will be site of the 2017 Student Launch Event coming to you live. Good morning. Welcome to, once again, Tony, Alabama. Bragg Farms is our location. We'll be having student launch. You'll see the teams that are from around the country for representing universities and high schools will be presenting their rockets that they actually designed and built themselves. This is just a step beyond hobby rocketry, folks. These are not these small ones that you can get at the hobby store. These are built by these students and are much more powerful. They have multiple goals, but the one that you'll be seeing here today is who can come closest to 1 mile in altitude. As I mentioned, Mother Nature certainly has provided us with a beautiful day. Just wispy clouds out on the horizon, but none right overhead, as well as no wind. That'll come into play a little bit later as we talk to our range safety officer. You'll learn a little bit more about that. But first, we want to introduce some of the folks who helped make this happen. It takes a gigantic staff of people, as well as some managers who are able to allow us to be out here today. But first, I want to bring in our new director of the Office of Human Capital at the Marshall Space Flight Center, just a couple of miles from where we are right now, Mr. Marcus Lee. And sir, we're so glad that you were able to be out here as well as help facilitate this great event.
Thank you very much. And on behalf of Marshall Space Flight Center, NASA, and the Office of Human Capital, I'd like to welcome everybody to our 2017 Student Launch Event. It is a great pleasure to have everybody out here on a beautiful day and to look forward to seeing all of the ingenuity that the kids have put forth. I'd like to thank our sponsors, Chris Harvey, and Mr. and Mrs. Chris Harvey, Mr. and Mrs. Dennis Bragg of Bragg Farms, Charlie Precourt of Orbital ATK. I'd also like to thank Maggie Clark and Dan Miranda of the National Space Club. I also like to thank the National Rocketry Association for their contribution and effort to this event. Also, Diane Detroit from the National organization. We appreciate that. Also, Diego Rodriguez. I'd like to thank them as well for participating. So just happy to be here today. Great to have all of the kids here and look forward to a wonderful event.
Thank you very much, Marcus Lee, with the Office of Human Capital, who helped oversee this entire event. We'll be talking to you a little bit later, but now I also want to bring someone who's also a little familiar with items flying through the air, a 20-year veteran of the U.S. Air Force, as well as with the Department of Defense and Missile Defense Agency, and now the Director of Science and Technology at the Marshall Space Flight Center, Dr. David Burns. Good morning, sir.
Good morning. What a beautiful day. It's exciting to be able to see so many enthusiastic students, mentors, educators, and volunteers to make this event possible today, to celebrate the 8 months of hard work that went into getting to this point. Educational activities like the student launch help develop skills in science, technology, engineering, and math that are needed by NASA's current and future workforce. As we prepare for future missions, we are looking for students like you to help us get there. We'd also like to thank the educators and mentors. You have provided the students with opportunities and experiences that can only be granted by the most dedicated. You have sacrificed personally to provide an invaluable experience to students from all backgrounds. I hope this process has been exciting and inspirational for you as it has been for us watching it. Let's go launch some rockets.
Fantastic. Dr. David Burns, the Director of Science and Technology Office at Marshall Space Flight Center. And last but certainly not least, we've talked to someone who has had some experience when it comes to helping guide these kinds of rockets. But now we've got to talk to somebody who's actually ridden on one. Veteran NASA astronaut and Vice President of the Propulsion Systems at Orbital ATK, Charlie Precourt. Good morning, sir.
Good morning. Thank you. And it's a real delight to be here again. Orbital ATK has sponsored this event now going on 10 years. This is our 10th anniversary, and we're delighted to do so. I had the privilege, as you mentioned, of riding space shuttles and piloting them for many years of my career, and it's great to see that we can hand off a legacy for kids to do better than that, even as we go to venture to Mars in the future. Today at Orbital ATK, we're really proud to be building the Space Launch System and the Orion system that will take us beyond low Earth orbit again, out to Mars. And this is a generation of future scientists and rocket engineers and astronauts that are going to make that happen. So I was really thrilled to see all of the ingenuity that goes into these projects. Really amazing, the capabilities of the future, the students here that are our future workforce. I understand there are over 600 students here today from over 24 states, and it's just exciting. We got a beautiful day, so looking forward to the tremendous launch activities today, and good luck to all of the teams that are here. Thanks for the opportunity.
Oh, you bet. Thank you, sir. And I know I'm going to kind of embarrass them just a little bit. I know you and I have both been out here quite a few times over the years, and I know as enthusiastic as the students are to launch their rockets, I know you're just as enthusiastic to see them fly.
Absolutely. You know, I used to do this when I was a kid. I can remember doing the Estes rockets when I was in grade school, and just having some hands-on project like this is so inspiring to kids to see that they can actually take what they're learning in school and apply it. This is way more impressive, as you mentioned, than the small hobby shop Estes rockets. So good for them.
Oh, yeah, those hobby rockets are certainly the entry, but then, of course, they get to step up to these. And who knows, maybe we'll see some of these folks help us design the rockets for the future. Charlie Precourt, Vice President of Propulsion Systems at Orbital ATK, and, of course, veteran NASA astronaut. We appreciate you taking the time to be here, and we'll talk to you a little bit later. So once again, we're only a few minutes away from starting the first rockets on the pad, but before we do, let me head over to our broadcast colleague, Chris Blair, standing by to talk a little bit more about the safety aspect of this event. Chris?
Thank you, Bill. Once again, it's my pleasure and privilege to continue to co-host this event, my third year, the 14th year of student launch. A lot to talk about, and we're joined by one of our special guests. If you would, sir, please introduce yourself, tell us your name and your role here at NASA Marshall.
Okay, my name is Chuck Pierce. I am a NASA employee, so I work here at NASA Marshall Space Flight Center. The role that I'm playing today is I am the range safety officer for this event. So it's my job to monitor the range and make sure that all the operations are conducted safely.
All right, so let's talk a little bit about the safety issue then, because obviously that's one thing that's always a concern for everything that we do, all these NASA education activities and exploration activities. And so what's some of the first things that you all worry about in regards to these students building these rockets and launching them here today?
Well, safety is always first. So as the students are putting their rockets together, we always want to make sure that they're mindful of the propellants and the devices that they're working with, because they are high energy. So have to be cognizant and know what you're working with. Once we come out to the range, we actually have this range set off so that only people with the rockets are allowed on the range. So from this area on down that way is a closed range, and we've got plenty of distance, 250 feet to the first rack and 500 feet to the second rack. So the rockets, when they launch, are going to be well away, so that if something bad were to happen, the fallout and the debris will be way down range.
Okay, and so we're talking about, these are high-powered rockets. This is, a lot of people think of the small Estes rockets that you launch, and those are great activities, wonderful for kids of all ages, and for big kids of all ages. But these are high-powered rockets, and so let's talk about the solid rocket propellant systems that they're using. Ammonium perchlorate, is it gunpowder? What are we using to get these rockets off the ground?
Okay. So the Estes rockets are compressed black powder. These propellants that we're using, they are composed of ammonium perchlorate composite propellant. So it's basically the same propellant that professional rocketry uses. The shuttle rockets, it was the same basic propellant, and a lot of these the composition is very close to that. These motors, the Estes motors typically go from a A rating to a D motor. The motors we're flying today are K motors and L motors and some J motors. And as the letter goes up, the impulse doubles, which is kind of equivalent to energy. So these rockets are 30, 60 times more powerful than an Estes rocket.
Nice, 30 to 60, and I love the content you provided us, that this is some of the same kind of material used in the Space Shuttle SRBs, the solid rocket boosters, and so real-world engineering coming into play here at Student Launch, our 14th year. Now let's talk about the drift distance. If we're launching a mile high, that makes sense, but it doesn't mean it's going to come right back down in the same area. So what kind of drift ratio are we talking about here in distance?
Well, we always try to maintain at least twice the distance to the perimeter of our field as the altitude is projected. So we've got plenty of space. We don't have any wind today, so there should be very little drift. Typically, when rockets launch, they will cant into the wind to some degree. These should fly pretty much straight up and come pretty much straight down. We will cant the rails a little bit, about 5 degrees away from the crowd, just to make sure that everything is angled away, because we don't want anything to come over the crowd ever.
Okay, that sounds great, and it's been wonderful having you here. We appreciate it.
Thank you.
We wish good luck to you and everyone else who's joining us today. Thanks a lot. We appreciate it.
Okay, thank you.
And so, once again, it's a wonderful event. This is a real display of scientific fortitude on display. It's not just, like we mentioned, not just rockets, small-powered rockets. We're dealing with sophisticated rocketry, carbon fiber, 3D printed materials. Here, you pass this down for me, please. Thank you. These real-world scientific engineering payloads. These kids have spoken to astronauts throughout the week. They talked to NASA engineers, scientists. Came out to Von Braun Center last night for a show and tell rocket fair. There's a reason why they call this place Rocket City. And so, that being the case, we got some teams joining us here today, sir. If you would turn your mic on, please, and tell us your name, where you're from, and what year you are in school.
My name's Corey Kochman. I'm a senior in high school. We're from Western High School, Davie, Florida, suburb right outside Fort Lauderdale.
It's wonderful having you all here. We really appreciate it. And so, first, tell us a little bit about your rocket. What's your nickname for your rocket? Do you have one?
Yeah, we call it, it's all red, so we went with Ares, the god of war. So we basically just that.
Okay, and high school teams have different versions of competition and challenge levels than the college teams. High school teams, you guys just choose whatever scientific payload. And so, a payload is what's going to be on top of the rocket. These rockets aren't empty. So, think of a payload. It could be a satellite or a spacecraft or an astronaut. So, we don't launch empty rockets that would not serve any kind of scientific purpose. High schools get to choose what kind of scientific or engineering payload. What was y'all's choice?
So what we're doing is we're measuring the cell growth rate of potato skin cells before and after a launch. We're going to see how the changes in pressure and the rapid changes in acceleration are going to go ahead and really affect the cell growth rate compared to a control that we have down on the ground.
Okay, cell growth rate of potato skin cells. That's, once again, we mentioned this is real-world scientific engineering going on. What's the benefit for that kind of research?
Being able to see how cell growth rate changes in such rapid conditions can really see how launches go ahead and go change microbial life. Like if we're having any sort of cultures going on a rocket, if it's going long distance such as to Mars, or see if it's going to low Earth orbit, we can really see how those effects happen over the short term.
All right, is there another member of your team who wants to talk a little bit about the design process of the rocket, how you all built it?
Yes, sir.
Absolutely. Same thing, if you would introduce yourself, tell us your name and what year you are in school.
My name is Adam Hussein. I'm a senior in school. So basically our rocket is constructed out of fiberglass body tubes. We have a nose cone. It's a what kind of nose cone? Yeah, it's a parabolic nose cone.
Okay.
We have a coupler section here, which houses our entire payload. There's an Arduino inside, and then above is 5 petri dishes that contain the samples. Here, this black piece of fiberglass is our avionics bay. The main parachute is housed in the midsection. Our drogue parachute is housed in the lower, and our fins are made of carbon fiber.
So you said you have 5 petri dishes.
5 separate petri dishes.
And is there any distinction between the 5? Are they all the same kind? Different potatoes?
No, they're all the same potatoes. We just want to see different sample sizes, so we have more of a test to see.
Awesome.
Yeah.
That's great. Okay, excellent. Is there anyone else who wants to talk about some of the people you would like to thank for helping you all be here today? If you would, sir, say the same thing, your name and your year in school.
Hi, I'm Joseph Callahan, and funny enough, myself, Adam, and Benny are from Piper High School. This year we worked in conjunction, Western and Piper
Excellent.
High School. And I really want to thank our wonderful sponsor, Miss Murphy. She's really helped us out, and Chris Marsulo. He's been instrumental in this process. Shout out to our proud principal at Piper High School, Mr. Gomez, because he's always supporting us in all of our different endeavors.
Okay, excellent. If you would, turn the mic off on the switch there. Thank you for joining us. We really appreciate it. I want to encourage everybody to stay tuned. Follow us on social media. Use the hashtag Student Launch. Ask your questions. We have an ACE staff here joining us on social media all day, answering questions, streaming live on Facebook, Student Launch Facebook, as well as on NASA TV, Twitch, and our NASA Marshall Ustream account. Stay tuned. We're going to cost a break and let you see some of the beautiful shots here at the Student Launch Field for Bragg Farms here at Student Launch. We appreciate it. Thank you.
Good morning. Welcome back to our live coverage of the 2017 student launch event coming to you from Tony, Alabama. While we have a moment as the range is open for students to start loading their rockets on their pads, we wanted to bring in the launch control officer, the man whose dulcet tones you'll be hearing throughout most of the day, Art Upton, of course. He's going to be the man with his finger on the proverbial button. So tell us, first of all, a little bit. You're with the National Association of Rocketry, and you've made it down here year after year to conduct this. Why do you keep coming back?
Well, it's really great. The National Association of Rocketry has always been designed to help students learn how to perform safe rocketry and enjoy it at the same time. And the NASA student launch, partnering with the National Association of Rocketry, creates a synergy and combines both organizations together. And the students really enjoy it and have a great time, and it's great to be able to volunteer and enjoy rockets, of course, at the same time.
So what's the kind of things that you impart upon the students as they come up here about the process?
Well, they have the RSO process where they have to safely check the rocket in, make sure that their checklists that they've assembled as part of the educational process have been followed. We've got check-in officers that make sure that every piece and part of the rocket was done the way the checklist said. They come up to the front here. A pad manager assigns them a pad and takes them down to the launch. At that point, when all the rockets that were ready to launch at one particular salvo time are ready to go, the range is closed to students. Everybody comes back behind the safety line, and then the process, the launch control officer, the pad manager, and the rocket spotter are a team at the front table to orchestrate the process of the actual launch.
And I think something, though, you mentioned that is most important that we do impart upon the students is safety. Safety's got to be number one especially when it comes to rockets of this strength.
Yes, rockets and safety. Safety is number one.
So you've got a lot of experience when it comes to not only running events like this, but also in launching rockets yourself.
Yeah, I started back in 1969 as during the space race. Everybody was rocketry was everything back then. And I saw a National Association of Rocketry magazine called The Model Rocketeer. Opened that up, went down to the local hobby store, and it's been rockets ever since.
Well, we appreciate you being here again this year, and we'll be looking forward to hearing your commentary as the launches go up. Art Upton with the National Association of Rocketry and our launch control officer today. Thanks a lot, sir. We'll be back with another team headed out to the range in just a moment. Stay with us. Welcome back to our live coverage of the 2017 student launch event from Tony, Alabama. We're now here with another team that's chomping at the bit, as it were, to get out there. Chris, who have we got today?
Excellent, gentlemen. Glad to have everyone here and ladies joining us. If you would, sir, tell us your name, your year in school, and what school you all are representing.
So I'm George Eller. I'm from Newport High School in Bellevue, Washington, and we're from Newport High School.
Excellent. So the state of Washington all the way from the other coast. It's wonderful having you all here. Bill, we'll go down to you. Let's I believe that gentleman's going to explain a little bit about the rocket for us.
Sure. Okay, first of all, what is your name, sir?
My name is Rex Orth.
Okay, Rex, so what did you have to do with your rocket? What part did you play in this?
So I designed both the experiment and I did a large part of designing the rocket itself. So the rocket itself is made from phenolic tubing, 6-inch phenolic tubing. The entire rocket is 122 inches long, and we have a fiberglass fins and a fiberglass nose cone. So phenolic is not as fancy as like carbon fiber or like 3D printed. It's just one of your standard rocket tubing things that you can get off pretty much most websites. And
So our experiment, our payload, unfortunately we're not going to be launching it today. It was originally a glider that would deploy its wings out when it was ejected. It would eject from the rocket after the rocket reached apogee and had deployable wings that would deploy and lock into place so that it could glide back to the original launch location. Unfortunately, we weren't able to flight test it before the final deadline, so we had to launch a mass equivalent. So we have a 5-pound tow hitch in there. That was done. I'm done.
So for our friends at home, I'm sure as you imagine with something that this is quite frankly ballistic, testing is an important part of the procedure, right, Chris?
Absolutely. So you guys have tested this rocket, would assume at least a couple times before you came here to student launch?
Yes, that's correct. So we went all the way out to Tri-Cities in eastern Washington to test the rocket. This was before we had painted it, and we were right up against the deadline to get the rocket tested. And this was before we had the experiment, so we were looking around for what we could use as a mass equivalent. And this man was kind enough to give us his old trailer hitch to use. So we put that into the payload and launched it, and it was a complete success, and that's why we're here.
So does your rocket have a nickname?
Yes, it's called the SS Botany Bay.
That's a Star Trek reference.
The Botany Bay?
Yep.
Good job, buddy. That's a great name.
So who did the work here on the spray, the artwork here on the side that I can see?
That's one of the members who's not currently with us on the trip. So that was our Finnish engineer, Claudia Yaw.
Excellent. Well, guys, best of luck to you. We're going to let you out to the range. First of all, say hi to everybody back home. I know it's really early way out on the West Coast, but I'm sure hopefully they're sitting there watching once again the team from Newport High School.
All right. Thank you.
Thanks, guys.
Thank you. Good luck.
Welcome back to our live coverage of the 2017 student launch event from Tony, Alabama, alongside Chris Blair. I am Bill Hubscher, and we'll be once again bringing you launches throughout the day. And just in answer to some folks have already asked on social media if there is an actual set launch schedule. There is not. It depends on when the teams come to the firing line, have to go through safety and get a pad assignment, and then turn in their launch card as they go ahead and put their rockets out on the pad. And Chris, we do have a rocket out there ready to go.
Yes, absolutely. We've got several teams joining us from all around the United States. Western High School is the team that's on the pad right now. So let's take it over to the Launch Control Center here, and they can get us ready for today's first launch of our 14th annual student launch event.
All right, we've got Western High School here with their Aries rocket. It has a baked potato experiment to determine the effects of acceleration on potato and spud growth. Flying on a J415, it's going to try to get the mile project. It's on pad 50. Is pad 50 armed and ready to go? Is pad 50 armed and ready to go? Pad is armed. Sky, is the sky clear, spotter? Sky is clear, range is clear. We're going to send this rocket up in 5, 4, 3, 2, 1, start. And it's still going up. Whoots and hoots from the crowd. The rocket's still climbing on its smoke trail. It's starting to arc over now, and we're going to look for an event. We've got spotters here. Let's hear when we see the event. Yeah, we've got the event reported. You see that little puff in the sky out there. The rocket's now safely into two pieces, and it's going to come down at a safe but faster speed than it would on a parachute. We're going to wait for it to come down now. We've got spotters looking for it. Any reports? The rocket looks safe. If you can see it, point to it. Okay, we've got people pointing to it. It's a small rocket, and it's really hard to see the sky. It's coming down on an orange drogue parachute. We've got a couple spotters pointing to it out there. If you can see it, point to it to help others. It's going to pop a main parachute at 600 feet. The spotters have it. It's coming down now to a decent altitude. We should be able to see it pop its parachute very soon here. There's the main. All right. Nice, beautiful sky and a nice, beautiful parachute coming down. Way to go, Western High School. Aries rocket. First rocket launched of the NASA Student Launch Program. Listen to the crowd. The rocket is now about to touch down. The rocket's safely on the ground. All right. We'll let the range manager declare that the range is open now. The range is open. Okay, well, remember, folks, when you're recovering your rocket, only to bring 2 people up.
Welcome back to the student launch coverage here at NASA. And while Western High School is headed out to recover their rocket, we want to let everybody know, don't worry, we won't be going one at a time and taking breaks. We're encouraging multiple teams to get out there on so we can launch them one after the other in groups. I'm sure it'll go a lot faster now that everybody's arrived and is starting to slowly put their rockets together to officially get them out there. But in the meantime, while Western's headed out there, we wanted to bring in another team. This is one of our high school teams. It's actually a conglomerate of multiple high schools from AIAA Orange County out in California. Is that right?
Yep.
All right, well, welcome, guys. We're glad you could make the trip here to North Alabama. We're going to talk to Albert. He is one of the team members here. So, Albert, tell us, first of all, a little bit about what you've got here.
All right. Our rocket measures CO2 levels in its payload. So we placed our payload inside the nose cone. And the idea is just to measure the CO2 levels 1 mile in the troposphere. It's a fairly straightforward payload, and that's pretty much all it does. But I think we could also focus on the air brakes themselves. So our rocket has autonomous air brakes. It uses an algorithm to control it, and we use a circular servo to symmetrically deploy the air brakes and adjust the velocity of the rocket as it ascends. After apogee, the air brakes won't be used, and we will just rely on the dual deployment system of our rocket.
So who was in charge of the air brakes project, or was it kind of a group thing? Okay, hang on, I'm coming down here. What is your name real quick?
I'm Sahil.
Okay, so Sahil, are these the air brakes right here?
Yeah.
The blue flaps, and they'll deploy. Now, is this something that's going to deploy as it gets closer to 1 mile to try to hit that target?
We continually deploy after the motor burn time is over. So we usually get about 15 corrections by the time we reach apogee. And it continues to correct over time, and the corrections they deviate less and less.
Because as we mentioned in the past, one of the awards that they will give out here is which team can get closest to 1 mile. And so we're hoping that you guys are able to do it. Last question really quickly. I noticed you did not go with trying to prettify your rocket. No painting, no decorations. You went kind of bare bones on this one. Was that a conscious decision, or was it you were working so much on the engineering you didn't get time to actually slap a coat of paint on it?
Frankly, it was to be more functional, so we didn't really have we felt like we didn't want to add the paint on. And it looks fine the way it is. It's beautiful. It flies beautifully, and we hope that we can reach that 1 mile target altitude.
And that's the important thing right there. Albert, thanks very much. AIAA from Orange County, California. Thanks, guys. Let you guys check in and head on out to the pad.
Thank you.
All right. Oh, we've got another team ready. Chris, I'm actually going to let you talk to these guys because they look like, well, this is the other end of it. They definitely put a lot of work into working on the looks of their rocket.
Excellent. Thanks, sir. Appreciate it, Bill. Wonderful to have you joining us and always doing a fine job. We got teams coming everywhere. We're going to interview some on the way out to the launch pad, some on the way back from the launch pad. And so I've got a young team right here. Would you please tell me your name, what year you are in school, and what school you represent?
My name is Kathleen Hockey, and we represent McKinney High School.
And where's McKinney High School at?
In Texas.
All right, great state of Texas being represented here today, folks. Teams from all around the country are joining us. Tell us a little bit about your rocket. First, does it have a nickname?
We named it Big Al.
And is there a reason for that?
We had a member that launched with us that recently passed away, so we named it in his honor.
That's a wonderful thing. It's great to see you guys honoring a tradition like that. And so tell us a little bit about your rocket. What's it made out of? How long did it take you all to make it?
So we made our rocket out of blue tube and phenolic tube. It probably took us a couple of months to build this because it's a very big and complex rocket, as you can see.
All right, and then we also have some payload content. So here, let's have you stand here. And if you would, sir, please tell me your name and what year you are in school.
Hi, my name is Alvin Calvin Isaac. I am currently a junior at McKinney High School.
All right, so high school students get to choose which kind of payload they would like, some kind of scientific or engineering payload. What was your all's choice?
As a high school, we actually decided to move towards college challenges. We chose two of which, fragile payload protection, and we also decided to go towards upward orientation or landing challenge. Our target upright detection.
Excellent. And is there anyone you'd like to thank about helping you all get here today?
Yes, we have a whole line of sponsors that we actually went out to. They proudly helped us out. We actually got a couple guys from Raytheon. We have a couple people from DARS. We'd like to thank, Emerson as well. Mr. Gupton. And Mr. Gupton. So, Jack and Susie, thank you very much, Jack Sprague and Susie Sprague. Thank you very much.
Excellent, wonderful. Appreciate it. Everybody wave to your mom, dad, all your family back home. We'll let you all head on out to the launch pad. And we'll encourage everyone to continue to watch our live coverage of our 14th annual student launch event taking place here just north of NASA's Marshall Space Flight Center in Huntsville, Alabama, affectionately and accurately nicknamed Rocket City. Stay tuned.
Welcome back to our live coverage of NASA's 2017 student launch event, coming to you from Tony, Alabama, a few short miles from NASA's Marshall Space Flight Center in Huntsville, Alabama. While we've got a moment, as a couple other teams are on the course, we want to remind you that once again, you can follow our conversation on social media. Just use the hashtag student launch. We've got our social media team is here addressing your questions as best they can, and they'll kick some of them to us for us to address live here on the air. And while we've got a minute, I wanted to bring in Dr. Katie Wallace. She is with the Academic Affairs Office at the Marshall Space Flight Center, who is, of course, one of the organizers and managers of this event on the NASA side. Dr. Wallace, thanks very much for taking the time to talk to us. I know you've got a busy day ahead, so I'm not going to keep you too long. But one thing I wanted to address and let some of the folks know is not only is the challenge about designing and building a rocket and making it to that 1 mile in height, but we actually put payloads inside the rockets.
Yes, that's correct, and we try to change the challenge every year. This year there are 3 payloads or 3 experiments that the teams can do. The university teams can select from the 3. The first one is target detection, where we've got a target in an unknown location. They have to find it and identify the 3 colors on the targets. And the second one is fragile payload protection. We give them an unknown payload, and they have to fly it and land it safely and prove to us that they've done that. And then the third one is the ability to control the rocket's roll and counter roll.
I know that's got to be difficult for them. That means that they've got to be able to, in order to image the field around us and be able to locate first and then identify what's on there.
Correct.
And then now, when it comes to the fragile payload, you've officially told them what it is now, right? You kept it a secret till this morning.
Correct. We gave it to them this morning, and it's actually small clay pigeons about the size of a silver dollar.
Right.
And there are 5 of them, so they're stacked together.
They try to keep each of them individually as safe as possible.
Correct, yes.
On the launch. Fantastic. And of course, the other one is to, I guess, to improve stability. That challenge of stability, as most rockets, a lot of them will spin as they go up to try to make it so they'll steady up as they launch.
That's correct. Yes, and then we also have high school teams participating, and they can select their payload. It's a scientific payload of their choice.
I love that we're able to kind of impart upon them that it's not just about the smoke and fire, which is awesome, don't get me wrong, but we're here for scientific purposes as well.
That's right.
Awesome. Well, Dr. Holmes, why do you decide to come out to this every year? I mean, obviously you do it, professionally, but still,
right.
as encouraging the students to come out here has got to be pretty cool.
Right. No, it's exciting. This is the high point of the year, the culminating event, and it's just so exciting to see all the hard work pay off. And, this is where the fun is.
Awesome. Well, Dr. Katie Wallace, once again with the Academic Affairs Office here at the Marshall Space Flight Center. Thanks for taking the time. I know you've got a very busy day, so hopefully we'll catch up with you a little bit later, okay?
Thank you.
Awesome. All right. Well, we've got a couple of schools out on the pad, and they'll be launching here in just a few minutes, so stay with us for more coverage from the 2017 student launch event in Tony, Alabama.
Good morning and welcome back to our live coverage of our 14th annual student launch event taking place just north of NASA's Marshall Space Flight Center in Huntsville, Alabama. I'm Christopher Blair, joined by my co-host Bill Hubscher, and we've got another one of our wonderful teams from around the United States joining us today. Cornell University is in the house. If you would, sir, please tell me your name, your year in school, and what you're studying.
Hi, my name is Kevin Liu. I'm a sophomore mechanical engineering major. So to describe the rocket, it's a 9-foot fiberglass rocket with a 5-inch diameter. One special thing about it is it has 3 separate ejections. So when it's descending, it will have 3 sections coming on its own recovery systems.
Excellent. So that's one of the things. We're going to talk about telemetry data and payload. So, Bill, you got some gentlemen down there ready to talk about telemetry.
Sure. Connor is down here toward the business end of the rocket, and I guess you were one of the payload lead team. So, first of all, tell us a little bit about the specific payload you chose to launch in your rocket today.
So, we actually did the target detection system. So, one part of our rocket, the actual middle part, is going to be landing upright. And then we have a clear section that you can see down by Kevin that actually is constantly taking images as we are as the rocket's on ascent. And so that's how we are getting all the images that we'll be processing and attempting to identify the targets.
Did you have to deal with any of the stability issues while it makes the ascent in order to get a good, clear picture of what's on the ground?
So we did, and we did that by kind of half taking on another of NASA's challenges, which was the roll control system. And so we have flaps that are able to deflect, and we'll be working on those in the future too. That will enable us to control the roll of the rocket, and that should, in theory, in the future, allow us to get better images, certainly.
So one thing that I know we discuss a lot about is the engineering aspect of the rockets as far as, again, pointy end up, making sure it is. But we got to ask, because it's so pretty, who was responsible for the design of the look of this rocket? Quite frankly, I love the fact, tell us about why we see brick on this.
Oh, sure. So our rocket is named Ezra, who is the founder of Cornell University, and Cornell is known for its clock tower. So our rocket, as you can see, we're rolling it over, is basically a large clock tower. And the brick design is because our rocket, the clock tower is made out of brick.
I love it. It's beautiful, right, Chris?
Absolutely. A lot involved. It's not just the design of the rocket. It's also all the engineering payloads that are involved in this. And so could you please tell us your name, your year in school, and what your role was in this year's designing of this rocket?
Yeah, my name is Brian Zhang. I'm a sophomore in engineering physics. So I was in charge of the landing mechanism. So it uses 12-inch polycarbonate that the 2 cameras can see out of, and then it uses 4 15-inch carbon fiber legs that get deployed at apogee, and it's coming down on a 90-inch cross parachute that should spin the payload to help reduce swing, and hopefully it lands upright.
Yeah, and so once again, we're talking about landing the rocket. All these rockets have to be designed to be reused and launched within just a matter of hours. Landing year after year, we have to make these challenges more complicated. We found last week with Rover Challenge, we've had to add new design challenges, and the same thing for this year. For our viewers who remember last year, we had a lifting mechanism to bring the rocket up to a vertical and a horizontal or a vertical position at launch. To make it more complicated, we've added the engineering and design challenges. You're talking about the landing detection system, actually landing your rocket vertical upright. That's an amazing. Have you guys tested that? Has it worked yet in the past?
Yeah, we tested it and it works.
I'm looking for good things today, Bill.
Absolutely. This should be exciting. But now, one thing that also has been asked of us on social media quite a bit is they'd like to know a variety of the disciplines that that everyone is studying. So what are some of the majors that we've got here today? Just shout them out so we can. Mechanical engineering, computer science.
What was yours, sir? Electrical engineering, applied physics. Thank you. So you see a lot of those STEM fields. So a lot of folks are asking, what can they study? Well, obviously you can also study a little graphics design, because that's just as important when it comes to again, for the final look of the rocket. Who can talk to us a little bit about some of these sponsors, some of the folks that helped you make this happen? Was that yours, Stephanie?
We're really thankful to a lot of our platinum sponsors, which a lot of them are located on here, and others like Blue Origin or Boeing, and Cornell especially, for supporting us through all the funds that we need to help build this rocket.
Yeah, what about your sponsors or teachers or advisors? And I think I see one ducking back there.
Yep. I don't know where she is now, but Rebecca McDonald. Rebecca McDonald, thank you so much for helping us throughout the year and helping us build this rocket.
Yeah. She's a little camera shy, I guess. We're just getting the big group photo here. So nice work, guys. It's a beautiful rocket. Everyone say hi to your folks back home who may be watching further up the coast in Ithaca, New York. This is Cornell University, once again from Ithaca, New York. They're going to be heading out to the pad to launch their rocket here in just a few minutes. Thanks, guys. Good luck.
Take the rocket real quick. I didn't get a good one with that. Awesome.
sipping something strong till we like what we find. So throw up your hands if you like what I like. Throw up your hands if you like what I like. Gotta blow off some steam, gonna have a good time. So throw up your hands if you like what I like. Throw up your hands if you like what I like. I got more on the radio blasting all night. Truck bears a case that I'm thinking just might keep the party going till the morning light. So throw up your hands if you like what I like. Yeah, throw up your hands if you like what I like. 'Cause this was for all the party jeans painted on just right. She slid on over, said, baby, put her in drive. And I was like, alright, got all night to make tonight what we wanted. And it starts with taking a little ride, following the moonlight, chasing it to the riverside. All night, ain't got nowhere we gotta go for right on the radio. We can roll till tomorrow sunrise, just hold on tight. Baby, let's take a ride. I wanna see her hair blowing in the window, with her pretty hand hanging out the window, and the other one resting on my shoulder. Every curve's got her leaning in closer. Just gotta hold her, baby, let's ride. Following the moonlight, chasing it to the riverside. All night, ain't got nowhere we gotta go. Daddy on the radio, we can roll till tomorrow sunrise. Just hold on tight, and baby, let's take a ride, and fly. Just name that distance.
And it's flying a K-55 to a mile to analyze CO2. I've got range spotters. Sky is clear. Range is clear. We're going to send this rocket up in 5, 4, 3, 2, 1, start. There's the ignition. It's got the flame. It's going. Come on, it's going to start. Come on now, everybody up and look at this rocket. This isn't normal, so let's keep all eyes on the rocket. Heads up! Heads up! Okay. It's got the chute on one piece. That was a slow start engine is what that was called. It cuffed at the beginning and had enough pyrotechnic charge to eventually light the engine, but then it was underpowered and could not overcome the weight of the rocket and had a malfunction and a failure. Next up, we've got Kruger School of Applied Technologies on pad 12. It's the Mark Twain IX. It's got spore fins to determine G-force effects. And on pad 12, we're going to go up in 5, 4, 3, 2, 1, start. There it goes. It's over the crowd's flight line, so everybody point to it, please. It's arcing over now. It's on the smoke trail. We're looking for the event. There's the event. We've got what looks like a rocket on a nylon recovery harness heading to the south. It's coming down stable as it should. Yeah, it's looking at about 3,000 feet. Rocket's at about 2,000 feet right now. And it's going to have the main parachute deploy at 700. I think I get far out. Imagining yeah, probably there. Almost to. We should have a main deployment right about now. Where's it at? I got no main on. No main on the chute, and it's on the ground. Next up, we're going to have Madison West. Is Madison West ready? They've got Reggie's Veggies. Okay, on pad 62 on the signs, we've got a K1999. Sky's clear, range is clear. We're going to send these up in 5, 4, 3, 2, 1, start. That was a fast-burning motor, and it's coasting. Coasting. Very straight flight. It's got the event. The rocket is under a drogue. There's still some of the tracking smoke, as you can see, coming out of the rocket while it's coming down on the drogue chute. It's coming down to about 2,800 feet, and it's going to have a main deploy at 700. You can see the parts of the rocket there. We've got the drogue parachute, a payload section, a rocket booster. It's coming down about 1,800 feet. We're looking at about 1,500 feet. We're looking for a main at 700. It's about 1,000. That's about 800 right there we go. Ah, look at that nice parachute, multicolor in the blue sky. That's a nice flight. Madison West. Okay, next up, we have Flying Lions, McKinley High School. Would you like to pause and try to figure out your interference, or should we go with this? Give me a yes or a no. Are we going to go on McKinley? Okay, we're going to move to another rocket. Oh, that's it? Okay, then you're going to scrub that flight, yes or no?
As far as I know, the other Talamega is just blue. Are you on 43455? What frequency? 43455. The rocket you're getting from this way.
Okay, they're going to wait for the next round and fix your telemetry and disarm the pyrotechnic.
Range is safe.
Do a little dancing, little kissing, just staying up late, do some moonlit wishing on a star. That's what you are, baby. Just step your way back into my arms to the song, stealing a fiddle. What good is life if we ain't gonna live a little? Come on,
Hello, folks. Students with telemetry, please listen. Please listen. We're using an Altistel Metrum and are currently powered on.
If we ain't gonna live a little.
Welcome back to our live coverage of 2017 student launch, just a few miles from NASA's Marshall Space Flight Center in Huntsville, Alabama. Joined now by the team from Spring Grove High School in Pennsylvania. And so, guys, you're about ready to head out to your pad, but we wanted to steal you just for a moment. Adam, I guess you're one of the leads as far as the engineering design for the rocket. Tell us a little bit about your design.
Well, our rocket, it's 108 inches tall. It has a 4-inch diameter, and it's about 25 pounds.
So you went for a very tall rocket, but as I said, 25 pounds, that's pretty light.
Yeah, we use fiberglass, and our fin can is actually 3D printed from our sponsor, TE Connectivity.
Do you want to talk about any of the other advisors or sponsors you got that helped you put this together?
Yeah, sure. The MDRA, Maryland, Delaware Rocketry Association, that's where we launched about once a month, and they just helped us get all of our flights in, and I think that's about it. We've gotten a lot of sponsors from M&T Bank, Rudders, a bunch of places.
It's great that you had a community that's willing to support you like that.
So these tall rockets that we launched, we also carry a payload of some kind, and I believe you want to explain a little bit about the payload. Would you tell us your name and your year in school?
I'm Sarah Staley. I'm a sophomore at our high school. So this year we're using Oobleck. It's a non-Newtonian fluid, and when you press on it, it solidifies, and when there's no force on it, it liquefies. And we're basically testing what it does under G-forces.
And is that something you guys are doing with a telemetry data system during flight, or is you getting that data after flight?
We're getting the data after flight.
Okay, excellent. And so, also looking at the rocket right now, how much does it weigh? We got the height and the diameter, but about
25. It's actually 25 pounds.
Okay.
Or 24.8.
So is that heavier? You guys are a stalwart. You come year after year. So how does that compare to last year's and previous year rockets?
It's heavier.
It's definitely heavier than we've past had.
So real quick show of hands, who here is considering this now as a career after this experience? This may be something you'll pursue in the future, do you think? There you go. Cool. Awesome. Excellent. Well, guys, thanks very much for coming out here. We're going to let you get your rocket on the pad. Once again, this is Spring Grove High School from Pennsylvania here at the Student Launch Challenge. And we've got another couple of teams heading our way, but we'll talk to them in just a moment. We'll let you guys go say hi to everybody back home.
I guess. Recovering from the pain. Well, if you have, say goodbye. Why'd you have to do it so damn sly? 'Cause that was harsh, a real harsh girl, like a little smoke with no high. everywhere I look. Folks acting like they wrote the book. See, they're the next big thing. They're living the dream. They cast the line and got the world on a hook. But it's not reality, just the real they want you to see. Covered in half-truths, tall tales, loose facts, blown out of skill. Driving names in the bin ears, built up with smoke and mirrors. They set up like a house of cards, so they'll look bigger than they really are. 'Cause talk's much cheaper than paying your dues. So let that mouth run, it takes them far. Even though they can charge a hefty price, if it shines and the label looks nice. But it's all half-truths, tall tales, loose facts, blown out of scale. Drive names in bin ears, built up with smoke and mirrors. And it doesn't take too long for it all to come down with a crash. As smoke clears, someone shatters the glass with half-truths and tall tales, loose facts, blown out of scale. Drop names in the bin ears, built up with half-truths and tall tales, loose facts, blown out of scale. Drive names in the bin ears, built up with smoke and mirrors. Smoke and mirrors. Smoke and mirrors. When my days are long, it's hard to carry on. I know I can turn to you. I know I can turn to you. And when the sky is dark, make the clouds part. Yeah, that's what you do. Yeah, that's what you do. And I'll never be the same. 'Cause sunshine, smile, you've got the love I need.
Good morning and welcome back to our live coverage of the 14th annual student launch taking place just north of NASA's Marshall Space Flight Center in Huntsville, Alabama. We are joined by one of our local stalwarts, one of our local teams here representing Huntsville. Glad to have them here. So, sir, if you would please tell me your name, what year you are in school, and what school you attend.
I'm a senior at the University of Alabama in Huntsville.
And tell me about your role in the design of this rocket.
I was the upper airframe team lead. So we handled the recovery electronics and the GPS tracking system.
So recovery, electronics, GPS, tracking. Once again, we've mentioned throughout the broadcast that we're not talking about small stage Estes rockets. These are single stage, but these are high-powered rockets. And to get them to a mile off the ground, which is one of the target, it's the target altitude. If you go above and beyond, you actually get a point deduction. We're targeting it exactly on a mile. And so it takes a lot of energy to get this rocket off the ground. How do you all do that?
We're flying on an Airtech L2200. It's a 6-inch diameter body frame, fiberglass. It's about 53 pounds wet and should hit that 5280 mark.
Awesome. Have you guys tested this before and hit that mark, over or under? How's that work?
We have tested about 5 times. Yes, 6 full-scale flights. We were tinkering with the ballast, so we feel confident that we have it handled this time.
Oh, big words. Awesome. All right. Well, hope that happens. And we also want to talk about the payload. We mentioned each rocket that launches is not empty. It has to carry some kind of scientific or engineering payload. And so we've got special co-hosts joining us throughout the day. This one represents the SLS department, our Space Launch System department. So, Tamara, if you would introduce yourself and then who you have to talk about the payload.
Absolutely. My name is Tammy Statham. I work in the Guidance, Navigation, and Mission Analysis branch at Marshall. I'm a trajectory engineer. I'm really excited to see this just because these are our future engineers that are going to be helping us with SLS and future vehicles someday. So we're really curious about this payload here. So could you please introduce yourself and tell us a little bit about which payload option you chose?
Yes, my name is Daniel Ireland, and I was the payload team lead. So what we chose the roll control option. So what we have to do is after the motor burns out, we have to induce 2 rotations of the rocket and then bring that rotation back down to 0. And we're going to do that by using those 3 external controllable fins right there. And they'll pitch once the motor burns out and bring the roll.
Absolutely. So what kind of sensors do you use to make sure that you actually are achieving that roll?
So we have a 9-DOF IMU. So we have an accelerometer and a gyro. So it reads accelerometer data, and that's how it determines when the motors stop burning. And then once it does that, it takes in the gyroscopic data to read what direction it's rolling and how fast. And then it goes in through a code that we wrote to determine what angle the fin should need to pitch.
Excellent. This is great content for all our viewers who are watching on Student Launch Facebook. You can also watch on our NASA Marshall Ustream account. Please feel free to talk and chat and share and ask questions. We've got an ACE staff that's going through and engaging right now. And so some of the questions we're getting on social media, some people have asked, what are the red tags for? Could you tell us that, please?
Definitely. So I actually didn't handle this, but those are removed before flight pins. So those are stuff we're going to take out before we actually do this to make sure avionics is working and that sort of thing.
All right, and then a lot of teams have a nickname for their rocket. Do you guys have a nickname as well?
We do. It's Viserion, which is one of the dragons in Game of Thrones.
A Game of Thrones reference. We had a Star Trek reference earlier for Botany Bay, so now we got Game of Thrones. That's awesome. We're having a wonderful time here at Bragg Farms, just north of Huntsville, Alabama. We'll be here for several hours. Usually we make it to about 2 o'clock. If you're in the area, feel free to come on down. This is a free event. It's open to the public. Grab the kids, bring a lawn chair, get some sunscreen because it's a beautiful day. We're going to let University of Alabama Huntsville head on out to the launch pad. Stay tuned. We'll be right back with more live coverage.
Welcome back to our live coverage of NASA's 2017 student launch, coming to you from Tony, Alabama, a few short miles from NASA's Marshall Space Flight Center. And while it does take a cast of hundreds of support to make this kind of event happen, it also takes some support from the management. And so we actually asked Jonathan Pettis, the Associate Director of the Marshall Space Flight Center, to join us for a quick minute. And sir, we're glad you could make the time to come out here today. Why is it important for you to come out here and see all these students at an event like this?
Well, it's just such an important initiative. That's part of what we do at NASA in terms of trying to be an inspirational entity for young people who are interested in science, technology, engineering, and math. And so it's part of what we do, part of what I feel like is part of our leadership responsibility is to show support for things like this, where we bring these incredible students here from all over the country who are inspirational in themselves in terms of their ingenuity, their passion, their inquisitiveness, and it's incredible what they're able to accomplish. And so we're just so proud to be part of it, and frankly, I'm honored just to be here and be around these incredibly bright young people.
I've seen a few of them with actual on their T-shirts, rocket scientists, and I think with these launches, yeah, technically, they could be considered rocket scientists, and we've got quite a few of those out of the Marshall Space Flight Center.
Yeah, absolutely, and we're, of course, very busy on the next major launch vehicle, the Space Launch System, and we're excited about that. And the kinds of capability that's required to create a vehicle like the Space Launch System is exactly what we see the early makings of here. And of course, we're excited about a launch in the not too distant future and moving to the next level of exploration of space. And Marshall's role in that is continuing. We're very proud of it. One of the things that this setting reminds me of is just the role that Marshall has played in the history in terms of farmland and cotton fields and rocket scientists all integrated together, and it almost takes you back to our roots.
Oh, sure.
In thinking about what's made such a big impact on the nation, but also in the community here. And this can't help but remind me of that. So it's kind of neat.
And I love letting these students get a chance to go through the entire process that we do on a much larger scale, of course, at the Marshall Space Flight Center, for when it comes to launching rockets, period, all the way from the reports and the design and the testing phases, all the way to the final test and getting out to launch it here as part of the challenge.
Yeah, absolutely. And that feeling you have right before launch, after all that work that's gone in to plan and put the infrastructure in place. I'm sure the students get a little bit of feeling like we get when we're that close, and sort of that same experience. But here we are in 2017, and the technology that's available and the sort of maturity of the capability to launch rockets. It's not an old science, really. It's not been around that long, but it's amazing how much progress we've made, and you see that today here with all of the capability that exists through these student teams.
Jonathan Pettis, Associate Director of the Marshall Space Flight Center here in Huntsville, Alabama. We appreciate you taking the time, and I know a lot of the students out there wanted to get a chance to talk to you perhaps about their future.
Yeah. Well, we'd love to talk to them. We're here recruiting as part of why we're here. I also want to just put a big round of thanks to all the team that's been part of making this happen. You guys are doing a great job here, and the Bragg family just allowing us to use their facility, and it's such a great thing for them to do, and we appreciate that, and all the team that's been a part of making this happen. Thanks to all of you.
Thank you, Mr. Pettis. We appreciate it.
Thanks.
We'll be back with more coverage from 2017 student launch event here in just a few minutes.
Good morning and welcome back to our live coverage of our 14th annual student launch. We are having a wonderful time here just north of Huntsville, Alabama. Beautiful day. Come on out and join us. Free event, open to the public. We're joined by, once again, another one of our teams from the great state of Alabama. We've got Auburn University in the house, and they are very excited to talk about their rocket. So first, please, sir, tell me your name, what year you are in school, and what you're studying.
Yeah, of course. I'm David. Nice to talk to you guys. I'm a junior, and I'm studying aerospace engineering.
Aerospace engineering, that's one of the many fields we've heard, electrical and mechanical and aerospace and chemical. So there's a lot that we'll get to talk about, and a lot of the questions on social media are, what are these kids studying? So it's great to hear that feedback. You got this wonderful rocket here in front of me. Tell me about your rocket. What's it made out of? What's the weight, the nickname, and all that?
Yeah, of course. So we have a 8-foot rocket. Monica, she's a beautiful one here. So right now she is 8 feet. She's 34 pounds, and she's a carbon fiber pre-preg layup. We got a couple of coats of paint on her. Nose cone is fiberglass, as well as the couplers here.
All right, fiberglass nose cone. You said carbon fiber was the body of the tubing?
Yes, sir.
All right, and then each rocket has to carry a payload of some form. We give them 3 choices to choose from. Tammy, I'm wondering what option did they choose?
Yeah, so if you could tell me a little bit about the payload option that you guys have.
Yeah, so one of our missions was we wanted to go 5,280 feet and induce a 360-degree roll and then undo it on the way up. In order to accomplish that task, our payload includes 4 grid fins. One of the coolest thing about grid fins is that they have a lot more surface area and a lot smaller package than a traditional fin. Another cool thing, too, is based on the design, the center of pressure is a lot closer to the rocket body, and so you don't need as large of an actuation system to really induce move them. We have 2 fairings right here. These ones are the altitude adjusting. Unfortunately for this launch, we couldn't get them fully working correctly, so they are static. But these ones just go out and on the way up, they control the speed of the rocket. So for, at 4,500 feet, we're going too fast, we're able to slow it down. And then these 2 on the side were conceptually supposed to be the roll inducing. So just like the altitude adjusting, they deploy like this, but they also have the ability to deflect a couple degrees in each direction in order to really induce that roll.
Absolutely. And what kind of testing did you do on your payload before today?
We did a lot of water tunnel and wind tunnel testing, really to get this, kind of the CP and see the, aerodynamic, I guess, the effects of it. And another thing too we did was add these fairings to really, kind of decrease the drag on the way up. These are made out of high density polyethylene, and these are 3D printed with ABS plastic. And we were lucky enough to get these dipped by a local company in Auburn by War Eagle Hydrographics. So we think it turned out pretty well.
Yeah, it looks great, guys.
Yeah, wonderful job. And so this project, for a lot of people, it's a year-long project for school systems, or it might be a senior program or a capstone program. And so it's an 8 to 10 month project. They usually begin at the beginning of the school year. They work on it all year long, and they usually means trials and tribulations, obstacles to overcome. And I'd like to hear what some of the difficulties you all had to overcome to get your rocket here today.
So one of our biggest challenges was kind of the dimensions of our team. We're kind of one-dimensional. We're predominantly aerospace. So we all had to kind of learn things that were not a part of our background of study. So, we had guys having to learn electronic stuff, and none of us are EE. A lot of mechanical moving parts in there. So it's just, kind of a lot of it was not a part of what we study in school. So we had to learn a lot of this.
That sounds great. It's a broad range of skills to be successful at student launch. We talked about center of pressure, center of gravity. This is rocket science, and so it's wonderful to have you guys here. What we're going to do at the end of the day, we're going to have our award ceremony at the United States Space and Rocket Center, the official visitor center for NASA's Marshall Space Flight Center. We'll be there where we give out several different awards throughout the day. There's best website. There's Team Spirit Award. And speaking of Team Spirit, what would we do if we're at Auburn University? Team Spirit.
So I think we got a big War Eagle here, guys. Whoa!
Eagle! Hey! There you go, Team Spirit in effect here at Student Launch. Please stay tuned as we continue our live coverage right here. Good luck to the best of you all. Let you all head on out to the launch rails, get your rocket set up, and I want to encourage you to continue to join us as we watch a wonderful day of student rocket launches all day long just here north of Huntsville, Alabama. Thank you for joining us. Stay tuned. We'll be right back.
Okay, the range is clear from the pad managers. Sky spotters saying the sky's clear. The first one up is Purdue SEDS on pad 21. They needed priority on a camera that's running. They also have roll control. This is going to fly on a K630 Blue. It's on pad 21, and pad 21's armed and ready to go on 5, 4, 3, 2, 1, start. Beautiful blue flame, but a bit of fishtailing on the end of the fin can. It's still stable, and it's climbing up and arcing over. Arcing over. Arc, there's the event. Now we see the airframe with a little orange drogue on it. It's coming down on the tracking smoke rather nicely. Looks like it got about 49, 51 maybe. 49.49, there we go. That was the best guess. The rocket is coming down now. It's separated into two pieces on purpose, separated by a nylon recovery harness. The drogue is on the payload section up at the top, and it's crossing about 28,000 feet, 2,800 feet. And you can see the airframes sparkle in the sky. We look for that sparkling when looking up at the sky to try to get a sight on it when it's too high to see. We look for the sparkle. The sun gleams off it's passing through about 1,000 feet. This is going to just got a main at 700. Beautiful multicolored chute in that blue sky coming down safely. Next one to go is pad 20. On pad 20, we've got we have a hold for an aircraft in the area. Okay, he's out of the flight area on the FAA waiver now, and it's safe to go. Back onto pad 20. We got San Marcos High School, Astronauts. Let's hear it from Astronauts. Are you ready to go? Air samplers, Apogee. It's going to collect an air sample at Apogee for CO2 contents. Sky's clear, range is clear. We're going to go in 5, 4, 3, 2, 1, start. Beautiful fast boost. And that yellow rocket looks really cool. It's still going! Arcing over just right about now. Looking for, there's the arc. Looking for the event on the arc right about, come on now. There we go. We got the event. I see a little sparkle up there. Going to try to be able to keep that in line as the smoke cloud passes us. Okay, we see the body tube sparkling in the sky up there on the recovery harness. This is look like it did not deploy a drogue. It is in separated, but it's going pretty good. I'm hearing reports that there's a tiny red drogue on it. Coming down into better visual flight vision here, it's about 2,200 feet to the dead south, near the middle of the road, still sparkling. It's going to have a main at 600 feet. There. There it is. There's it on the chute, folks. Right over the tree line, dead south, just to the west of the road. Okay, the next. The next one up is U.S. Naval Academy at Annapolis, the Navy Rockets. Let's hear a good applause for the service women and men. The Navy Rockets has an automatic target detection and landing system. It's going to fly on a K-1440. It's on pad 41. Pad 41 is armed and ready. Sky is clear. Range is clear. Going in 5, 4, 3, 2, 1, start. Wow. Quick burn motor. It's going straight up, straight up, straight, straight. Going straight. Still going. There's a little arc over. Going backwards. There's the event. We have 2 pieces rotating on the recovery harness as it should. We still have, no. The small one has a chute on it, a small drogue. It's coming down faster. And there's the main chute on the one piece. We got a second piece still up there. $700 feet. This second piece is going to have a main at 700 feet. Looking at about 700 feet right about now, and there's the chute. Beautiful chute on this guy. Next up is University of Cincinnati. Big Red Thunder Mark II. Target recognition and identification pad payload. Going on an L850 White Lightning on pad 52 out at the far piece. Naval Academy is just landing right now. Look at that beautiful landing. Give them a shout, folks. Pad 52 is ready to go. University of Cincinnati is going in 5, 4, 3, 2, 1, start. He's pushing the button very hard. Interesting whistle out of the nozzle of that motor. It's going a little bit to the northwest here. It's arcing over, and there's its first event. There's 3 pieces on that. Still over to the west, folks. If you look for the sparkling in the drogue chute, you can see it. There's a chute on the separate payload section now. See that white chute that popped? The science payload's on the white chute. Rocket boosters coming down on a drogue to the west. Chute's taking off to the south at a higher altitude, and it's climbing in a thermal. A thermal is when hot air lifts a parachute up instead of it coming down. The main is over to the west by the tree line, and there it is, the main chute. It's over by the tree line. The science payload is still floating on a thermal. Next up is Spring Grove, Pennsylvania. Testing the viscosity of a non-Newtonian fluid on ascent. K1000 Hard-hitting motor on pad 61. Sky's clear, range is clear. Going in 5, 4, 3, 2, 1, start. Beautiful whistle. Arcing over, there's the event. There's the separate pieces on the recovery harness. It's to the east side, a little bit south. This main is designed to come down at 600 feet. Still looking at about 1,800 feet right about now. 1,800, 2,000-ish. 12 or 1,500 feet. We're looking at a main at 700. Looks to be about 1,000 feet right now. 800, come on, 700. There we go. Wow. Okay, on pad 80, we need the Flying Lions of McKinley High School to shout if they're ready to go this time. Yeah, wait, there's a helicopter here. We're asking McKinley High School, are you ready to go or not? Yes, they're ready. We'll wait for the helicopter. While we're waiting for that helicopter, McKinley High School has telemetry on it. They've got it operational. They're going on an L1170 fast jack, so that's going to be a smoky motor. And we're going to have the main deploy at 1,200 feet. Nose cone is going to separate. They're using an Altus Metrum Telemega on call sign KG5RYB. Okay, helicopters out of the FAA waiver area. We're going on pad 80 out at the away cells. McKinley High School is going in 5, 4, 3, 2, 1, start. There's going up now, a little bit of a tail wiggle. It's arcing over the crowd. Please, everybody, point at it as it's arcing over. We're looking for an event. We're looking for an event. We're counting pieces in the air. Everybody point at the rocket. There's a piece falling. Heads up. There's a piece falling near the flight line. We have reports that it looks clear the flight line. It's coming more towards us over here. Everybody point at the piece. Heads up. Ooh. Another piece is coming down. That's the lander. Oof. The parachute is going to drift over the crowd. Please have people point at it. And the main booster is just off to the west. Oh, and pad 82, Charger Rocket Works of Huntsville, Alabama. Wow, listen to those woots and hoots. On pad 82, Charger Rocket Works. 82 is going in 5, 4, 3, 2, 1, start. A nice green flame. It's arcing over the crowd, a bit over the flight line to the west. Everybody point to the rocket. There's the event. Everybody that can see that rocket, point at it because it is north of the flight line. And the trajectory of that could cause it to pass over us. It's still coming down. Everybody point to it so everybody knows where it's at. It's going to have a primary main at 600 feet. And there's a jet going over at about flight level 280. He's really up there, but looks larger than he is. Coming through about 1,200 feet now. We're looking for a main at 600. There's about 900 or 800. 7. 6 should be right now. Come on. There we go. Beautiful orange and black parachute, just floating in that thermal. The heat from the fields lifts the parachute and provides more lift. At this point, once that actually hits the ground, we'll be ready to load more rockets. You can tell the heat off that field is making that parachute hold up in a thermal. There we go. Range is open and range is clear. It's all on the ground.
We're here with the team from the University of South Florida. They're just trying to gather the rest of them out here so they can have their moment to be able to say hi to all friends and family back home. But we also wanted to give them a chance to talk about their rocket. Andrew is one of the team leads here. So tell us a little bit about your design this year.
Well, we went with the largest possible, I guess. Stands at 12 feet tall. It's 47 pounds, and it's made out of fiberglass.
Looks good so far. We're hoping it'll do a definitely, pointy end up kind of flight. Tell us about some of the challenges that you guys faced in pulling all this together.
Well, a lot of the challenges we had were with the payload, designing it and getting it to work right. We had to start again fresh about a month ago, and we found out that our original design just wasn't going to work when we did the testing. So, and as far as the other challenges, really we have some excellent mentors who get us through every step of the process. And so, as far as challenges of the rocketry part, we just have some excellent mentors, and they really, really take care of us.
So you mentioned that you had a previous design that you had gone with. Can you tell us about some of the alterations you made?
Like I said, Simon would be a little bit better at that, but basically we started with a biprop design to guide it, and they were vertical, and they were going to guide it back towards the tarps and also correct for spin. And we tested it hanging from a rope, and it worked really, really well. It was going in the right direction. It was stabilizing, and then we put it under a parachute. Instead of stabilizing, it just kind of wobbled. So we just went with a more straightforward design using a swivel camera instead of using actually guiding the lander back to the tarps. Now it has a swivel camera.
Well, let me pop down here to Simon, who actually was a part of that payload team. So now that you've got it all locked in and ready to go, are you pretty confident in it?
Yeah, we've done quite a bit of testing with the image processing for the target identification, and that all seems to be going pretty well, as well as the camera on a gimbal to aim towards the direction of where the target should be. So I'm feeling pretty good about it.
Right, so they were able to, that's the one that you chose as far as one of the three alternate, or you got to select from the three, I should say, challenges as far as your payloads are concerned. So everyone here is a science engineer. What are some of the majors that we've got here?
It's kind of interesting. You have a lot of engineers here. Steph happens to be a physics major, and one of our members, Brett, on the end, is a finance major.
A finance major? Okay, hang on just one second, folks. You're the finance major?
Yes, I am a finance major.
Okay, so how did you get roped into this, and what is your role in this design?
I've been working on developing the organization, more so, working on implementing kind of an organizational structure, new management of sorts. This year we started with really just 3 or 4 returning members, and now we have 3 teams, 3 separate projects operating independently with their own teams. We have another team up at LTRS in Maryland right now. They should be launching tomorrow, and this whole team here. So we have about 30 active engineers in the whole organization. I've been working on developing some of the processes and things like that to operate at a larger scale.
And it's good that you're here because I think you get to be an example to those at home who may be thinking that it just takes an engineer or a scientist to work on an event like that. We need folks who have all kinds of different backgrounds. So good luck, guys. We're going to let you. Actually, you're not going to head out. You're going to launch on the next round. So we're going to let the University of South Florida do some last minute tinkering before they head out to the field. So we're actually going to have you guys take a step back and head back that way. We're not going to go quite to break because we've got another team ready to go. Oh, this is interesting now. We noticed them earlier. Penn State is here. our Nittany Lions, and they want to show off some of their rocket here. And are you guys going to launch on this round or the next one?
I think we're on the next one.
You're on the next one? Okay,
Yeah.
but we wanted to bring you guys in, and I know you're a little far down here because part of the thing that first grabbed my attention from walk that way just a little bit is we saw this part of your rocket from afar, and it's sloshing and moving around. Tell us a little bit about this, Luke.
So this is our fragile object protection system. It's filled with a non-Newtonian fluid, and that's our primary mechanism of keeping our payload safe. So as the fluid accelerates, it hardens in order to keep the payload in position so it doesn't hit the walls or anything like that. But yeah, we wanted to have an acrylic section so we could see it and show it off.
So I'm going to put you a little bit on the spot and explain to the folks at home who may not be aware what a non-Newtonian fluid is.
Okay, so a non-Newtonian fluid is a fluid that when it is under a force, it hardens rather than like spreading out like a liquid. So if you were to punch this, it would feel like you're punching a wall. But if you kind of just gently push on it, it would feel like water.
Yeah, the slower it goes, it'll stay liquid. But I guess the theory is that it'll be able to keep them firm as they head up and hopefully not break them.
Yep, exactly. Hopefully.
All right, so who wants to talk to us a little bit about the design of the rocket itself? Who's eeny, meeny, miny, who gets to do it? Okay. What's your name, sir?
So my name's Kurt.
All right, Kurt, what's your major in school?
So I'm a mechanical engineer. I'm a senior this year.
So as you take this on as, I guess, one of your senior projects coming down to graduation, tell us a little bit about your rocket.
All right, so our rocket is constructed of Blue Tube 2.0 this year, and so as you can see, it's quite a bit longer than our usual fare, but we figured that we wanted plenty of room for our payloads and also all of the little goodies, such as our down body camera down there, which is covered with custom 3D printed shroud, and we actually did a lot of 3D printing this year in order to make prototyping and manufacturing a lot more feasible, and you can iterate a lot faster. So our fin brackets down there are 3D printed. We have our camera shroud printed. And actually, to deal with the varying wall thicknesses and diameters of our acrylic section, nose cone, and airframe, we actually custom printed 2 3D printed transitions in order to accommodate for all of that.
Fantastic. Well, let me ask you now, as a senior, and you're, of course, coming up on graduation, what have you been learning from this whole process that you think you're going to be able to take with you into your future endeavors?
Definitely, I would say a lot of teamwork integration, just being able to be in a scientific environment where there's lots of people asking questions and constantly questioning each other. And I feel like a problem such as building a rocket, the more lights that you shine upon the same problem, you can reveal that many more defects and then come to an overall better product as a team.
That a collaborative effort that's very important. Believe me, we use it as well. Once again, this is Penn State University, Lion Tech Rocket Labs. I like that. Say hey to everybody back home, guys. We look forward to seeing your rocket fly.
Thank you.
Thank you.
All right, you guys can take a step back because we're just going to bring them through one at a time. Now we're going to meet a team that's already flown. You guys can head that way, and you guys come in this way. There we go. All right. So in case you probably aren't able to tell, maybe from the view you have, but this rocket has actually already flown. First of all, tell us your name and what school you're from.
Rabia, and I'm from Kruger Middle School.
Kruger Middle School, that's right, our only middle school team. But you guys have also, Kruger's Middle has been here quite a bit. It's 9 years now. Excellent. So you guys already flew. How do you think the flight went?
Successful because our payload is perfectly fine, but our ejection charges turned, and so we broke a little bit over here.
So when they turned, when that was for the main shoot or for the drogue?
Main.
So the main, and it just got a couple little holes in here. With some minor repairs, though, and because part of the challenge is it's got to be able to fly again. Not necessarily today, but it has to be kind of a turnaround as far as that's concerned. Are you very concerned? Oh, okay, that's a good angle. Yeah, seeing the ejection charge there. Are you think that with some minor cosmetic fixes, you'd be able to fly this again?
Yes. Most likely, yeah.
So who's in? Did you guys subdivide as far as the actual design of the rocket and the painting of it and your payloads?
Yes.
Actually, for painting, it was my grandma actually painted all the rocket.
Yeah.
So she was an excellent artist. I love the bird here.
Yeah, it was
nice
all
work.
hand-painted. And for the experiments, we have 2 teams. We have the spores and the fins, which are our 2 experiments.
Okay, so who was in charge of payloads? Was that you as well, or who would like to talk about the payloads?
I'm going to talk about payloads.
Okay, you talk about it.
Okay. So we had. I'm going to tell you about our fins experiment first. We did interchangeable fins. And we did those on our scale model. We saw if fin design affects the acceleration of the rocket. And so we got yes as the answer, and we got that the clip delta had the highest acceleration, and we needed the highest acceleration for our spores. we're trying to see if, with our spores, we're trying to see if G-force affects the germination of spores. So we needed the highest G's possible.
So what will be the next step as far as your payloads for the germination of spores is concerned?
When we go back to San Antonio, we're going to grow the spores that have flu and the spores that haven't flu in auger and see the difference in the growth.
Fantastic. Well, I look forward to seeing the results of that one as well. Once again, Kruger Middle School joining us from Texas. Guys, thanks for making the trip with the only middle school that participated in the event this year. You definitely should take that. We look forward to seeing, to tracking your careers as you move on to high school and college. Thanks very much, guys. All right, we've got a lot more coming, including a few more teams that are making their way out to the range. So we'll hopefully be bringing you those launches here in just a few minutes. You're watching live coverage of the 2017 student launch event from Tony, Alabama.
Wonderful day here at our 14th annual student launch event just north of Huntsville, Alabama. Come on out and join us. This free event is open to the public. Bring your lawn chairs. Come on out and see these rocket launches. We've had numerous rocket launches today. Very successful, launching a mile high in the sky, carrying all sorts of really interesting real-world scientific or engineering payloads. This is science in action. We're joined by an obviously well-dressed team right here. If you would introduce yourself and tell me who we have joining us today.
Yes, of course. So I'm Midshipman First Class Nick Ramsey. I represent the United States Naval Academy Navy rocket team. Before you have our Maverick rocket. We did the automatic target detection and upright landing for this year's mission. So I'll let my team introduce themselves now.
Excellent. So each rocket has to carry a payload. You guys did the landing zone detection system. Tell our viewers a little bit about how that works.
So we just use a camera to visually identify the ground and the targets, and we use a Raspberry Pi processor to process the imaging.
All right, so we're talking about onboard camera systems, real-time telemetry data, as well as software systems as well. So we've talked to a lot of people, aerospace engineering, but beyond that, it's a lot of electrical, mechanical. What are you studying in school, sir? And tell me your name.
I'm Midshipman First Class Gus Eaker. I'm an electrical and computer engineer at the Academy. So I was the avionics chief on this and set up the Raspberry Pi and did the detection.
All right, and so throughout the, how many months have you all worked on this project?
We've been working since September, so good 9 months.
What's the biggest obstacle you all had to overcome?
That's our one. So the academy is very time consuming, so just finding the time to work outside of class and fit all the mandatory military obligations in, as well as prepare to graduate and commission as officers in the next few weeks. So finding the time to balance everything, work together as a team. You know, I never knew Gus and Jer before they joined the project, so building a team and coming together in 9 months' time is no small task.
So how many people are on the verge of graduation? Raise your hand. Everybody. Awesome. That's awesome. STEM and college degrees at work right here. That's wonderful. And so we're also talking about, you know, obviously you guys work all year long to make this happen. Who are some of the people you'd like to thank that's helped you reach this far?
Obviously, we'd like to thank our mentor, Captain Barber, Major Castingway, our OREP, and Lieutenant Commander Timken. He's going to be taking over next year. So.
Okay. How many people were on the team last year? Are you rookies? Raise your hand. Who was on the team last year? So so you're the lead and everybody follows. All right, and so later on this afternoon at the U.S. Space and Rocket Center, we'll have an award ceremony where we give out a bevy of prizes: best team, best spirit, best report, best looking rocket, rookie team. Obviously, you guys have been here in the past, but it's great to have you joining us. Team spirit's one thing we're always interested in, so want to give a chance for you guys to give us a little bit of a raw or a cheer, or what is it that the U.S. Navy does to represent themselves when they're out and about?
Okay, all y'all go Navy. All right, 1, 2, 3. Go Navy! Free Army!
Oh, yeah, we've heard that one before, ladies and gentlemen. Wonderful representation. Thanks for joining us. We appreciate it. I want to encourage you to continue to watch our live coverage. We got teams joining us throughout the United States, nearly 50 teams. We'll be right back. Stay tuned.
Hi, my name is Tammy Statham, and we are here live at the Student Launch Initiative. I am here with a team from Virginia Community College. Could you please introduce yourself and tell us what you're studying?
Okay. So I'm Andrew Oxford. I'm our team leader, and I'm studying aerospace engineering at Piedmont.
Oh, that's absolutely great. So could you tell us a little bit about the payload option that you guys chose for your rocket today?
So we're going with the roll induction and counter roll challenge, and to do that, we're using a reaction wheel, which is essentially just a large heavy wheel attached to a motor, which we spin up, and doing that induces a moment of inertia, which causes the rocket to roll, and then to stop rolling, we just spin the motor down, and doing that allows us to fairly precisely control the actual roll of the rocket.
How precise can you control it?
That I'm not particularly certain on. That would be you guys.
Down to a couple degrees per second? That's great. So looking at your rocket, I love the design you guys have here. Who actually painted this? Anyone on your team?
It was actually a friend of ours.
Oh, that's great.
More artistic than any of us.
What was the inspiration behind the design?
So most of us, at least, are huge Tolkien fans. So the dragon is supposed to be Smaug, and then the name of the rocket up there and back again in Elvish, because we're all nerds. And then the script from the One Ring around the avionics bay.
That's great. So what year are you guys in college right now?
So this is my second year, effectively.
So sophomore?
Mm-hmm.
Absolutely. Well, good luck today, guys. We're really rooting for you. Your rocket's great.
Thank you.
Yep.
you
Introduce yourself.
No, I'm talking to him.
Oh, okay. Mr. Eaker, can you take a picture of me doing this? By all means. Thank you very much.
Hi, my name is Tammy Statham, and we are at the Student Launch Initiative in Tony, Alabama. We're just north of NASA Marshall Space Flight Center, and I'm standing here with the team that just launched the rocket. Could you please introduce yourself and tell us where you're from?
Yes, I'm Midshipman First Class Nicholas Ramsey. I'm the team lead for the United States Naval Academy team, and right now we are just getting back to our booth after a successful flight. So this year we did the mission 3.2 of target detection and upright landing. So right behind me you see our avionics and structures team taking apart our upright lander. So we're going to start pouring through our onboard flight computer and get specific data. So the way it works is at apogee, our rocket splits into two separate pieces. These legs come out off of spring hinges and a camera is exposed underneath. That camera runs off of a Raspberry Pi processor, which takes a live feed from the camera, scans the ground for the 3 targets that NASA planted, and we have to classify and identify each of the 3 colored tarps, and we have to save an image to prove to NASA that we identified the correct target. Once that is done, we're going to land on our legs. So debriefing the flight, we had a successful launch, the most important part. During descent, we got a little nervous because we didn't see our parachute. It came down a little bit quicker than we expected it to. But right around 700 feet, our Jolly Logic chute release deployed and our main came down, steadied everything out, gave our program a chance to run. We are confident that our avionics chief is now going to be able to see a classification of the images. And then the main booster section came down just as planned. So overall, really successful launch for the Navy team here. Full deployments. We had a good launch, and now we're looking forward to see what our specific flight numbers were, velocity, altitude, acceleration, and to see if we found our targets. NASA kind of hit them on us, hit them over a berm, so we couldn't see them prior to launch, but we're confident we were up high enough that we got a nice wide view of the farmland here. So really fun 8-month experience. It's all come to an end now.
Great. So during this 8-month experience, did your team have any challenges you've had to overcome in the design process?
So in the design process, as with any government contracting program, there's always some confusion about expectations. So we read the requirements one way, we go brief NASA on a proposed design and they say, no, you can't do that. So we had to go back 3 different times and redesign our mission. We first started out having a drone that would autonomously track the targets and land on top of the target, because in the military we like to hit our targets. But NASA said you don't need to do that, so we had to go back, took out the drone. Then we were originally inverted because it was easier to, over an arc of the flight, it was easier to come down inverted. NASA said you can't do that because that's not upright, so we had to go back and rechange our design. Then we ran into the issue of having our legs too far aft of the burnout center of gravity. So we had to go back about a month and a half prior to the competition, gut the entire rocket, and change every single piece we could to become lighter. We went from a 30-pound rocket down to a 18-pound rocket. So we cut almost 50% of the weight in about 6 weeks' time. And then we had to do another full-scale flight test with that new configuration in order to launch here. So the design challenges came in the ambiguity of the requirements and just us not fully understanding what they needed and us trying to be maybe too eager at first. We were too excited about, trying to be like SpaceX. So we need to tone ourselves down a little bit, and that caused the team a few road bumps, but I'm really proud of the team this year. We put together 3 different full-scale rockets, if you think about all the redesigns we had to do. So I'm really proud of the team. We've come a long way.
I'm sure it makes it today and actually seeing that launch making all the more rewarding for you guys.
Absolutely.
So is there anyone, an advisor, a mentor, any sponsors you'd like to thank for this?
So we have a huge support team at the Naval Academy. We have a mentor, Captain Trip Barber. He's been great all year. He's taught us things we never even think of. You know, we're about to go launch, and we forgot like the most crucial piece, but we never knew it. So that's why we have mentors. We'd also like to thank our 2 faculty advisors back at the Academy, Major Kristen Castingway of the U.S. Air Force and Lieutenant Commander Spencer Temkin of the United States Navy. They've been outstanding to us. They've really let us experiment and engineer this on our own. They didn't have any preset requirements in their head for this, so they let us experiment, learn how to be engineers, and really learn how to be officers, because that's our ultimate goal in the end. We'd also like to thank Captain Ken Reitler, United States Navy. He's a former astronaut on staff at the Naval Academy. He's really guided us in terms of how NASA looks at safety and how they look at requirements and really figuring out the government-contractor relationship. So we'd like to thank those 4 individuals.
Absolutely. Well, thank you so much for taking the time for this interview, and stay tuned for more interviews with our teams.
Absolutely.
All right, folks, as we get the pad managers up here to close down the range for the next round of flights. Okay, we're going to readjust an angle, so we're going to take a hold here. going to get ready here for the next round after some adjustments were made out at the far pads for safety. This is Madison West team, Wisconsin. Okay, as another announcement, there's 11 rockets out there, and we only have 8 flight cards. 9 flight cards. So we're missing 22. We're missing the flight card for pad 22. No, we got 22. Nope, we found 22. Okay, we found the missing ones are 11 and 12. Please come up to the safety.
Then I got a 40. Yep. All right, and then we've got 51. I got a 51. Got a 50. 50. Oh, 50 is here. Yeah, 50, 51. And no 50. 11 and 12.
Hey.
Hold on one second. We don't have. I don't have. We can have 11.
Just a reminder, when you come back with your rockets, the team leader needs to have the flight card and hand it to the flight card manager at the LCO desk.
Okay. All right. Let's do it. That's a good idea. What?
Okay, we're going to start here with Madison West first because of their batteries are lower capacity in the small rocket. It has a precision-guided landing vehicle. So anytime we have a precision lander in there, we want everybody to watch all the pieces that come out. The sky is clear. Range is clear. We're going to send up Madison West and the lander. Keep an eye on the lander on pad 50 in 5, 4, 3, 2, 1, start. Nice straight boost. Blue flame. It's still going like an Energizer bunny. It's coming over it's in the safe zone. There's the arc over. We've got a item coming down, but I did not see an event. We've got an item on a drogue. Okay, the pieces are still to the south of the flight line. The main deploy at 500 feet. Main's at 500. All right. Hear the woots over there at Madison West. Plantation High Team Termite. Running on it's on pad 11. Take a look at pad 11, folks. It's on a K828. Range is clear. Going in 5, 4, 3, 2, 1, start. There's a straight boost. Still going. Starting the arc over. Looking for an event. There's the event. And a drogue. We can see the body tube sparkling in the sky from the glints from the sun. It's passing the clouds of smoke. The rocket's going to have a main at 500 feet, so that's going to be a shallower one. Yep. It's to the west of the road, going at about 800 feet, about 700, 6, 5 should be right about now, but come on, lower. There it goes. There it caught, oh, there, now it caught some air. Awesome. Taking attention to pad 12, we got Plantation High School telemetry called the Strike. It's on a K828. Sky's clear. Pad 12 in 5, 4, 3, 2, 1, start. Nice smoky boost. Going up. There's the arc over. Looking for an event. There's a drogue out. We have a drogue out, and it's to the south. Still up there at about 3,000 feet. To our south, almost straight down the road, a little bit to the west. It's going to have a main at 500 also. There it is. Okay, there's about 7. There it is, 500. Next up, Northern Illinois, home school. Montgomery, Illinois. Pad 20 is where this is at with CO2 ejection on pad 20. K630. Going on pad 20 in 5, 4, 3, 2, 1, start. Nice thunderous roar, blue flame, still climbing. Arcing over. We're looking for an event. Saw a little cloud event. I see a drogue. Something's coming down a little bit fast, but there is a drogue on it. It's all solid in one piece. This has a main at 600 feet. Nicely to the south in the safe landing area. It's about 1,200 there. 8. There we go. 600 feet. Engineering and Technologies Academy at Roosevelt High School. This is pad 21. Take your focus on pad 21. This is a J415 White Lightning, stirring up the smog, collecting organic and non-organic particles. Looking at pad 21, checking the sky. Pad 21 is going to go in 5, 4, 3, 2, 1, start. Nice crackling in that white smoke. Still going up. There's the delay charge. Looks like it's going to arc over soon. There's the drogue. We can see the airframe sparkling from the sun. Another one at 500 feet. The main will deploy at 500 feet on this one like the other two. It's about the 1,500 feet level. Eesh. That's about 1,000. We're looking for a 500 here. It'd be 7, 6, 5. No chute came out. We had the event, but it's slow enough on the drogue in the safe recovery area. The rocket will be fine. Next up is the University of my hometown, Toledo, UT Rocketry. Let's hear a shout out for that. There they are. Cairo is their rocket on pad 22. Take a look at pad 22. This is going to have roll stabilization. So it's supposed to roll, stop roll, and roll again. Keep your eyes out on any of these rockets with roll control because we want people to follow them with their hands and let everybody know where they're at all times. Pad 22, the sky's clear. We're going in 5, 4, 3, 2, 1, start. Nice thunderous roar. Okay, it has crossed the flight line, so let's have everybody take a look at this. I want everybody's eye on this rocket because it has gone north of the flight line. We're looking for an event now that it's arced over. We're looking for an event. Okay, heads up. We have a ballistic rocket onto the west. I want everybody looking at it. And there's the main at the last. Okay, on pad 40, the Tarleton Aeronautical Team has a Spirit on pad 40 with an L2375. This is a big motor, folks. Oh, aircraft hold. Distance, Steve, for an L?
I think it's 300 feet for a simple L.
Yes, what my recollection is. But we usually, for safety,
we would put it further. We would push it out more. Technically, it's. I think technically it's legal. Well, what would you do? Hold it? He's got a good angle on it. Looks to me like he's got a pretty good angle away from the crowd. It's got roll control on it. It's got a pretty heavy, thick-ass motor, doesn't it? Yeah. Yeah. Let's go.
The RSO said launch it. It's official. Okay, on pad 40, this rocket has roll control. It has a hard-hitting L2375. It's on pad 40, which is a little close in. I want everybody's eye on the rocket because of the roll control. Sky's now clear of the aircraft. We're going in 5, 4, 3, 2, 1, start. I could feel that in my chest. The thump. Okay, we're looking for the event. There's an event. We have reports of the drogue. It's up there at about 42. It's going to pass through its own smoke trail in a little bit. It's at about 2,500 feet. It's off to the west, south of the flight line. This is going to have a main at 750. That's a nice, pretty shoot. We like to see the parachutes. On pad 51, this is also a roll computer on an L. On pad 51, Notre Dame Rocketry Team, you ready? This is an L930 roll experiment. Everybody's eyes on the rocket and point at it as it runs. Pad 51 in 5, 4, 3, 2, 1, start. You can hear a nice thunder off of that motor. It's climbing. We're looking for an arc over. It looks like a little bit of arc over. Now we're looking for an event. There's an event. It did not open. Heads up, everybody. Look at this rocket. The rocket's coming in hot. Rocket's coming in hot. They're empty already. Rocket's coming in hot. Saved at the last minute. On pad 82, the Loyola Marymount University, the big deal. Fragile Material Protection Project on an L1420 red line. This is going to have a main at 700. Sky's clear. Pad 82. 5, 4, 3, 2, 1. Hold on. Okay, this has multiple pieces and parts, so I want everybody's eye on the rocket. Pad 82. 5, 4, 3, 2, 1, start. The pad launch controller is showing an open circuit in the igniter. So we're going to have to recycle that one for the next round. Is 81 with all the pieces and parts? Yes. Hello. Pad 81. Is that the one with the light on it? Yes, that's the light. Pad 81. This has 3 separate ejected entities at the top. Each has dual deploy, and it has a lander in it. There's 3 pieces ejected at apogee. I want everybody's eyes on the rocket. Separate people to point to different pieces and parts. I need all the spotters on this I can get. Pad 81, an L1300. Going in 5, 4, 3, 2, 1, start. It's going off to the west and the southwest. That's a good thing. Arcing over. Looking for the apogee event of 3 separate items. There's an event. We should have another one now. There's the third event. No, we have 2 events. We're looking for the third. The main parachute altitude will be at 500. 1,200, about 1,000 there. 800. Looking for a main. Looking for a main now. There it goes. There's the lander. Yep. Okay, we need the flight card for pad 80. We can't launch pad 80 without a card. While he's putting in a new igniter for 82, can someone that owns the rocket for pad 80 please get their flight card up here so we can fly you?
82 pop the igniter. We have a card for you. You sure? I thought it was 80 that was recycled. This is the recycling.
They need their flight card to fly. Who is it? D44H. Team D44H, we need your flight card for pad 80 to fly you. There's 80.
I didn't mean to do that. Put it down.
Yes, you did give her the card.
Yeah, I didn't give her flight protection.
You gave us the card. It was ready for a while. Here's What motor do you have in it? And that's your okay, and that's your rocket out there. I know, that's the rocket. So, the one with the roaches. And I actually saw on your footboard,
Possibly. I can wait here. Yeah. Okay, it might have been stuck. All right, there you go.
all right, we've got the flight card for Pad 80. Thank you, 4-H team. D. Ford, Michigan. We have a pad manager putting in an igniter on the Loyola Marymount.
Acme Rocket Company. Fins and shreds. Complete service. Yeah, that's what we should do, Keith. Our next one should be a rocket that we fly a watermelon payload with like 8 fins. And so when it goes up and slices the watermelon, and we have a tarp there that we can go out and eat the watermelon. Oh yeah. There's that part. It's on the board. How about we just put stakes and blast it away? Yummy! Yeah. He's gone now. It sounds like he was over that laying low for a moment. I'll probably have one of you guys. I don't hear him now. He's down low somewhere off this way. I don't see anything, so you're good to go.
Okay, we're going to look at Pad 80. D. Ford Dazzlers, 4-H team. Yay! They have roaches in space. I've seen their capsule for the roaches. It's absolutely amazing. They've got an Aerotech K1050 White Lightning on pad 80. Sky is clear. Going in 5, 4, 3, 2, 1, start. Whoop! Two pieces. There's the main. Now we'll see if those cockroaches are still protected. I bet they are. They even had a heated habitat. So, okay, the next one up is on the end. It's pad 82. It's the Loyola Marymount University, the big deal. Fragile material protection with an L1420 red line flamed motor. Red flame, folks, on pad 82. Going in 5, 4, 3, 2, 1, start. There's the up part. It's going a little towards the flight line. I want everybody, it's over the flight line. I want everybody pointing at the rocket. It's arcing over the flight line now, just a little west of the road. It's still, we have an event. We have it under drogue. Everybody pointing at this rocket. It'll move to the south. It's now over past the flight line to the south, which is a good thing. It's at about 3,000 feet. This one's going to have a main deploy at 700. $700 feet will be the main. We're at about 9, 8. Should be right about now at 7. Come on. Go for the main. It's about 6. The backup charge should be, there's this backup charge. There it goes. Nice big X-Factor shoot. The first part of the rocket is down now. And the middle part, still waiting for the parachute. Now without that weight, it floats on the thermal. Floating on a thermal. Still hovering in the heat, and there it's down. Range is now safe and open.
Welcome back to our live coverage of the NASA's 2017 student launch event from Tony, Alabama, a few short miles from NASA's Marshall Space Flight Center. And we are here now with the team from UNC Charlotte, University of North Carolina, Charlotte. And John is one of the team leads here. So, John, tell us a little bit about, you say you work on the air brake system for this rocket?
Yeah, specifically I worked on the control system and the control algorithms for the air brakes. I took control theory back in last spring, so I kind of just solely focused on that, but I've also been here to help out in every section of the rocket.
It looks like you guys have done some, if I could just say the design on this, or maybe a little 3D printing on the nose cone. Who was the one who led off that challenge? So tell us a little bit about the actual design and production of your rocket.
All right, so the nose cone section itself is actually RP'd out of polycarbonate plastic. This section of airframe is fiberglass, carbon fiber with another fiberglass section. Our drag mod is polycarbonate RP'd, and we have another section at the end with the fin can that is also carbon fiber. And in the nose cone section itself, we also have a landing feet deployment system that extends after the rocket is descending.
So as it comes down, you expect this to help land in a vertical position?
Yeah, we're aiming to maintain a vertical orientation upon landing, yes.
Excellent. Now I want to come over here and talk to the gentleman who's in charge of the payloads. Now, each of the universities had three challenges, I guess, payload challenges from which they could select. Which one did you choose to go with?
We decided to go with the fragile material protection system because we felt like it'd offer an interesting challenge due to the unknown factors that we'd encounter. So it allowed us to create a versatile system using a vacuum bag chamber that constricted around the object, sort of like a food saver that you use at any grocery store for your food. It provides a uniform holding force around the object and keeps it constrained throughout the duration of flight, including our landing with our assist of the landing system.
At the risk of oversimplifying it a bit, were you concerned about maybe shrinking it and being too tight of a hold around those items?
That was, in fact, one of our concerns. We mitigated that through testing and verifying that with different objects, different sizes, and different material setups, that it would not break them under the pressures that we were going to be achieving.
Fantastic. Okay, everyone has come up with, all the different teams, of course, come up with ideas and different names for the rocket. So what did you guys name your rocket?
T4 Heavy.
Okay, how'd you arrive at that?
So when the legs come out, it looks kind of like the T4 virus, which is actually, we have a sticker somewhere on the rocket down there, which is the T4 virus. So it has a pretty great resemblance. So T4 just seemed to work, and it's pretty heavy. It's about 50 pounds. So
that's cool. Well, this looks like a great looking rocket, guys. We're looking forward to see it launch. Say hi to your friends and family back home. This is the team from the University of North Carolina, Charlotte.
Yeah. All right.
Hello, everyone. Welcome back as we bring you live coverage of the student launch event taking place just north of NASA's Marshall Space Flight Center. We've got Loyola Marymount joining us. It looks like it was a big success. Give me a big cheer. Let me just hear it. Was it a success? Yeah! All right, so would you please introduce yourself, tell me your name, your year in school.
Hi, I'm Gus. We go to Loyola Marymount University. I'm a senior mechanical engineering major.
All right, and so your role in the design of this rocket or payload, which one were you responsible for?
So I'm the team leader, but I'm also on the payload design team. Okay. We had a successful launch. I mean, the sensitive fragile did not break, and none of them actually, none of the 5. And so, if you guys want to hold them.
So all the rockets have to have some kind of payload. High school kids get to decide what their scientific or engineering payload is. There's 3 options for college students. One of them is to launch, recover, retrieve safely, I guess, an object of which they didn't know what it would be, how large it was, the size, the quantity. And so it's like a clay, was it a clay bird or a ceramic bird. So you had to launch these, recover these successfully. And how did you all prepare for that?
We decided to use some foam. We also had some backup CO2 systems. Today we just flew it with just foam and a mechanical spring system.
All right, so I see the rocket. It's nicknamed the Big Deal. Looks like you guys did a lot of work on it. Could you tell me your name, please?
I'm Kenny. I'm a senior mechanical engineer at Loyola Marymount. The rocket is 122 inches and 49 pounds, fully assembled and loaded. All the body tubes are fiberglass, carbon fiber fins, aluminum bulkheads on the inside.
And how long did it take you guys to come up with this design and then actually engineer and fabricate it as well?
The design took pretty much, we were making changes up until FRR, so almost the full 8 months. And yeah.
All right, how many people were you all here last year? Or is this a rookie team? Rookies in the house. And there is a rookie award, one of several awards we'll give away later tonight at the U.S. Space and Rocket Center, the official visitor center for NASA Marshall. And so there's a lot of work that goes on in the process, and also a lot of behind-the-scenes help that I'm sure you all get. If you would, could you tell me who wants to talk about thanking some of your sponsors and the people involved? Yes, sir.
So I'll thank some of our sponsors. I wanted to thank Shearer's Collision Center. They did our paint job. Looked out, awesome, really. We worked with SureFab. They donated a lot of our composites. Who else? Aerospace Corporation. We got to meet with their CEO. He gave us some feedback on our design. The CTO of SpaceX gave us some feedback. So definitely a lot of big names that helped us out. ADM for composites as well. So, and most especially that man right there, Dan Larson, the man himself, the Colorado kid, who is our advisor and who also recently just got engaged. So shout out to Dan Larson.
Congratulations on that. That's wonderful news. And so looks like it was a success, and we look forward to seeing you guys later at the awards ceremony.
Absolutely.
All right. Thanks, guys. I'll let you head on back that way. And so we've got several teams. Our next team's ready here to join us. Once again, universities, high schools, colleges, middle schools, even from all across the United States, have been launching rockets all day today. It's a beautiful day. We've had great success. We've probably launched nearly 30 rockets today. They go a mile high in the sky. It's actually a target altitude. There's a point system. If you can hit the mile mark, that's what you're targeting. If you go over or you go under, you actually get point deductions. That's one aspect. And so we've got Kendrick with us right now. Tell us what university you're from and what you're studying in your year in school.
I am a sophomore at Purdue University. I'm studying aerospace engineering, focus in propulsion.
All right, so Purdue, have you guys been here before? Are you rookie team?
Purdue has been at USLI before, but we've taken a long hiatus, and this is our first time back in a long time.
All right, well, welcome back. Tell us a little bit about your rocket. First, the nickname, and then what it's made of and how you all came up with that design.
Absolutely. So, the rocket is named after Roger B. Chaffee, who is a Purdue alumni. He perished in the Apollo 1 fire, so we named it to honor him.
That's great.
Yes, we named this. This is made of fiberglass, 3-inch fiberglass. It's roughly 9 feet tall, and it's a little bit more unique than most of the 4-inch rockets out there. We were flying the roll category. So actually the fins that we used were 3D printed and were held in a 3D printed bulkhead. There's also a 3D printed bulkhead in the nose cone. The centering rings we used were machined by our project director, Chris Nielsen, who gratefully donated his time and aluminum to us.
So was your flight a success? How do you feel about your flight?
I think it was a fantastic flight. I think it was absolutely beautiful to see all our work shoot up into the sky and come back down safely. I will say that the corkscrew that we saw, the roll, was quite nice, visually kind of impressive. I will say that we did fall quite a bit short of the altitude requirement, but you know, I'm out here to launch rockets, watch them happen, and this is a wonderful opportunity for everybody out here. I really enjoy it.
That's well said. Sir, we appreciate it. Congratulations on a great launch. We're going to go out to the launch rails and hear from Maria.
All right, we're here with St. Vincent St. Mary. Who do we have?
I'm Kevin Fiesel. I'm the payload specialist.
All right, well, welcome. Could you tell us a little bit about your rocket?
Yeah, our rocket is 8 foot 11 inches. It weighs about 22 pounds, and it has a CO2 gas sampling payload, which means we're going to measure the concentration of CO2 in the atmosphere from apogee to ground in parts per million.
So what is something that you're most proud of?
I'm proud of the way our team came together. We're a huge variety of people, and we came together to build this beautiful rocket on time, you know. We modeled it to go exactly 1 mile, so we really put all of our talents to use.
What was the most difficult part of working on this rocket as a team?
The most difficult part was our first test launch. Actually, this rocket was dragged through a cornfield, and it didn't lift off the pad due to a bad motor. So we had to overcome the slight damage to our rocket and really make sure that we had the right modeling done and that we could actually lift this rocket off the ground instead of dragging it in a cornfield.
Gotta love those cornfields. All right, well, we're excited to watch the launch today. Back to you.
We're here now with a team from Madison West High School. It is high school, right? Not the middle school team, because I know you've had middle schoolers on your team before. They're here almost every year. Wisconsin. We're glad they were able to make the trip down here this year. A little bit warmer, I guess, than you're used to back home. Jason's going to tell us a little bit about your rocket design. How do you think the flight went?
We're pretty happy with how the vehicle performed. We're not sure if our payload actually worked, and we're not going to know that until we get a chance to look at the flight data. But we're really happy with how the rocket performed, and we got a safe, perfect deployment, and that's the main important thing. So
yeah, I'm going to put her on the spot because you actually laughed at that. Were you not sure if it was going to survive as it came down?
Well, I mean, it went perfectly. It just sometimes they don't. So
and that's why you tested a lot, right? All right. So what was your payload actually?
So we decided to build a smart lander. So we had an imaging system in the nose cone of the rocket that photographed the ground below it.
This part here?
So this is the imaging system in the nose cone. There's a little window in the tip for a Raspberry Pi camera to look at. So as the rocket's descending, it's imaging the ground below it and looking for hazards like water and trees, and it's going to avoid those and aim for the red spots because the dirt here is so red. And then, so it determines what it thinks to be the best landing zone that it can reach based on wind speed and its current altitude. And it relays that information to the reefer system, which is Melinda is holding. And so that's located on our drogue parachute's shroud lines. And so it pulls the shroud lines in or lets them out, which restricts the effective diameter of the parachute and changes the descent rate to increase or decrease how far it drifts.
So it's essentially able to steer it a little bit.
a little bit, yeah.
The direction is entirely determined by the wind, so we can't really steer it, but we can control how far it goes.
Fantastic. So what have you learned during this challenge that you think you're going to be able to take with you as you move on to further endeavors?
I think one of the biggest challenges that we faced early in this project is that the basic design that we had in mind for the reefer system just didn't work how we had planned it. So we had to completely redesign the thing and figure out a totally new approach to how we were going to restrict the shroud lines. And so that's a really important lesson that I'm going to carry on with whatever I end up doing past rocketry, to just not get stuck on the first idea that you get and to still consider other options.
Lots of exploration when you do those testing. Thanks a lot, guys. The team from Madison West High School, one of the teams, I should say, from Madison West High School in Wisconsin. First of all, say hi to mom and dad and friends and family back home. Congratulations on a successful flight. Let's head on back out to the launch pads and see who's on deck.
All right, we're here with the University of North Dakota. Who do we have?
James Sutton.
All right, welcome, James. Could you tell us a little bit about your rocket?
Yeah, so we have a payload protection system, which you can't see. It's in the top of our rocket under the nose cone. And then when we production, the
One of the teams from Plantation High School in Florida just recovered their rocket. This is the team Termite, is that correct?
That is correct.
Okay, first of all, how did you arrive at that team name?
Well, it is basically made from our payload. We are actually launching live termites to investigate the forces of flight on how they can forage, and this is used because on the ISS they're testing to see if they could use termites to kind of digest plant matter like stems, leaves, roots that humans couldn't digest. So this could make the ISS a bit more efficient and recycle a lot of the things that they use.
All right, so Adam, you just brought in your rocket up from off the field. How did you feel about the flight?
The flight actually looked very beautiful. It went straight up, and we don't have the altitude quite yet. We're going to take it over to the judging stands, figure that out. No major damage, just a couple scrapes and a lot of dirt. It's a pretty dirty arena, but it was a phenomenal flight.
So, what your termites, as far as you know, are still encapsulated in the rocket that you've got there?
Yes, they're still in. We have not checked them yet, but we're about to run our experiment when we get back.
Cool. So let me ask Sean and Loretta real quick. So why did you guys decide to join the team and become a part of this challenge?
Well, it was mainly because I'm actually in the aerospace program and I like rockets, and when we were thinking about this payload, I thought it was a really cool idea and I wanted to join that team to do so.
Oh, so you actually had a hands-on with the termite payload itself. Cool. What about you?
Well, I joined the team. This is my first year doing SLI, and I was really comfortable with this group of people. So I was like, okay, this is the team I'm going to join. And I was really happy that we did this payload because it was exciting, and it was like a live payload, so it was very interesting.
It'd be interesting to see how the termites reacted to when you get back out under a microscope. Adam, let me ask you then, what's it like though trying to pull the ideas and thoughts of so many different people together to build this kind of a machine?
It does have some struggles. It's not too easy at times, but when it all comes together at the end, it's a really beautiful thing.
Excellent. Well, guys, I want you to get a chance to say hi to everybody back home. This is the team from Plantation High School in Plantation, Florida, the Team Termite, and their successful launch. Congratulations, guys.
Thank you, sir.
Okay. Take two. Hi, folks. Welcome back to our live coverage of the student launch event here in Tony, Alabama, just a few short miles from NASA's Marshall Space Flight Center, where university and college teams from around the country have gathered to test their designs of their self-built rockets. Once again, these are not hobby rockets. Their target is 1 mile in altitude, and a lot of them are coming very close. This is Charleston State University, and I wanted to show this again. Wearing a t-shirt that says 3-0. Would you explain to us real quick what that means?
So the past 2 years for the Centennial Challenge, we won prize money 2 years in a row, and this is a gift from my grandmother. She figured we'd do something good again this year, so I'm wearing it for her today.
Grandma, that was awesome. Great Christmas gift, and hopefully it works out for you. First of all, who was in charge of the payload for this particular rocket? Okay, why don't you step on up here real quick. Tell us a little bit about the payload. You had 3 options to choose from. Which one did you decide to go with?
As a team, we decided to go with the roll control, where we control the rocket after motor burnout for the 2 revolutions, and we think it went real well.
So were you able to see the spin or stop spinning as it went up?
Well, we have the data on board, sir, so we're going to check that as soon as we can.
Fantastic. So how did you arrive and get to arrive at this particular design of your rocket when it came to size and engine and everything?
Because of the design we wanted to go with direct drive rudder system, we needed a diameter large enough and a motor small enough so we could fit our servos in between that space.
Cool. So let me ask actually bring you to it. I know you're hanging back because you don't want to talk, but let me ask you, why did you decide to get involved in this challenge?
Thought it would be an interesting experience, and I like rockets, so let's see what we can do with it.
Well, sometimes it's all you need. What are you studying at Charleston?
We're actually technical writers, so we edited the documents, document design.
And once again, showing that it's not just the engineers and the mathematicians that actually get to work on rockets. So we need people who from all walks who do all kinds of things with all different kinds of majors. So, guys, once again, take a look here at the camera and wave to everybody back home. They had a successful launch. Charleston State University. Now let's head on down to the launch pad and see who's almost ready to go.
All right, we're here with Newport Rocketry. What's your name?
My name is Rex Worth. I'm George Eller.
Welcome. Could you tell us a little bit about your rocket?
Our rocket is 122 inches tall, weighs about 23 pounds, 6 inches wide. It's made of phenolic tubing. The nose cone and fins are fiberglass. We're running this on a... What motor is it on? It's a K820. K820. And it should go up about 5,000 feet. So that's pretty much, those are the main facts. We got 2 flight computers in the lower eBay. We have 2 telemetry systems in the upper eBay. And unfortunately, we are not being able to fly our payload because we weren't able to flight test it before the final deadline. So we were originally going to fly a glider that would deploy wings at apogee of the rocket and come out and glide back to this GPS location. But unfortunately, we weren't able to flight test it at home due to bad weather, and therefore we're flying a tow hitch instead.
All right, what are you most proud of your rocket?
Oh, that's a hard question. I would say I'm proud of. I built a telemetry system that's in the upper eBay. It's from Arduino, so I selected all the chips and I did most of the programming. So I'm really proud of that, the fact that it's working and functional right now.
All right, great. Well, we wish you luck today.
Thank you.
All right, back to you.
All right, continuing our coverage of student launch, we've got teams everywhere. Teams out the launch rails that are getting ready for the next round. We got teams that have completed their launch today and get a chance to get some feedback on how their launch went. So Plantation High School Team Telemetry, the second of their teams, are here. Would you please introduce yourself?
Hi, I'm Mitra Kujerman.
And what year are you in school?
I'm a senior.
All right, so tell me a little bit about actually first, do you consider was your flight a success?
It was definitely a success.
All right, and so what gauges it as a success?
We had a very straight flight. Our rocket landed safely with the drogue deploying at main and the drogue deploying at apogee and the main deploying at 500 feet, and our payload collected data. So everything was safe and good.
All right, so as we mentioned, each rocket has to carry some kind of payload. High school teams get to choose which one they want. College teams have to choose one of 3 options. And so you guys had a data system that you're able to actually track multiple data points. And so real-time telemetry, you're downloading that on laptops. What kind of data points are you collecting?
So we're collecting barometric pressure, temperature, GPS location, acceleration, orientation, and compass heading.
That's a lot, and you hear cheers in the background as this is a lively event, real-time science in action. And so as we move on down the rails here, we've talked a little bit about the payload that the students have on the Plantation High School rocket. Is there a nickname for this?
It's called the Shrike.
The what?
The Shrike, our rocket.
Okay, and moving on down, would you introduce, what's your name, sir?
Hi, my name is Adam Kotler.
And your year in school?
I'm a senior at Plantation High School.
All right, so tell me a little bit about the design of the rocket. What's it made out of? How much does it weigh?
Well, the whole rocket is composed of fiberglass. The airframe, the nose cone, and even the fins are all fiberglass. And for the paint job, we just wanted a really sleek design with our Plantation High Aerospace logo.
Okay, and how much does the rocket roughly weigh if it's all made of fiberglass?
It's pretty lightweight. The rocket weighs about 14 pounds in full configuration.
14. I talked to one team earlier. Theirs was nearing 50. And so the weight of your rocket is going to determine also kind of the propulsion system, how much energy you need to get it off the ground. And so we've been talking also about the kinds of degrees these students are studying. It's not just obviously rocket science, science, technology, engineering, math, the basic STEM fields. When you go into college, what's one of the fields you want to study?
I'll be looking to study computer science at the University of Central Florida.
All right, and tell us your name, please.
Daniel Mazo.
All right, so computer science at whatever school you get into. Another great segue into the idea that this team obviously built a rocket, designed it, tested it, launched it, flew it. It's a success. But also the computer software program kind of really, if you're interested in that, works great for this telemetry, decide for your payload. Why did you all decide to use that payload?
This payload was basically a reattempt at something we've done in the past. We wanted to improve upon what we've done before and do it better.
Okay. How do you feel about that?
I feel we did an adequate job at achieving what we planned on doing.
Excellent. You set goals, you achieve them. That's what we do at NASA, at all the NASA centers across the agency. I want to congratulate you all on a job well done, and we'll see you at the awards ceremony later tonight. Thanks a lot. Let you guys go this way. Wonderful opportunity by another group of high school students that are joining us from all across the country. 24 states are being represented here today as we're bringing another one of our high school teams and also another stalwart team that's been here year after year. And it looks like we've launched. Have we launched? Excellent. So would you please introduce yourself? Tell me your name and what year you are in school.
My name is Danny, and I'm a junior in high school.
Okay, and what school?
Madison West High School in Madison, Wisconsin.
All right, Madison West has a great social media presence. They also bring 2 teams, so you can follow them online. Which team are you all?
We are the junior team, which is Team Arabidopsis.
That's a lot of syllables. Okay, so excellent. Tell me a little bit about your launch. Was it a success, and if so, why?
Our launch was beautiful. It was a really straight flight, and all of our deployment worked perfectly. And we got our payload out and did our post-flight procedure with that, and there were just no hitches. It was beautiful.
Okay, excellent. What was your payload? Can you explain that? Is that you or someone else? Payload, please. This is it right here?
Yep. So our payload we flew Arabidopsis thaliana plants, hence the name, in order to analyze how the stress of rocket flight affects their expression of genes related to gravitational stress.
Okay. And is that a real-time data point that you collect, or is that something you go back afterwards to analyze?
It's something we do analyze afterwards. After the flight, we have to fixate the plants, which means to basically use a chemical to freeze them so that we can analyze their genes later.
Okay, genetic research as well as plant research is definitely something that we do at NASA. A lot of that research is done on the International Space Station, and so you guys are really following in the footsteps of what we do at the agency. We want to wish you all the best of luck and say congratulations. Wave to your folks at home. Everyone say hi.
Oh, can we shout?
Oh, yes.
So I just want to give a couple shout-outs. Thanks to the botany team at UW-Madison, specifically Dr. Richard Barker and Professor Simon Gilroy and Jerry Mao for all their hard work and helping us to build our payload. Thank you, guys.
We thank them all as well, and we thank you. Thanks for joining us. We appreciate it. We'll see you at the awards ceremony later tonight.
Thank you.
Excellent. We've got teams everywhere. Bringing the next team in. Is this correct? All right, so we'll let them come on in. Once again, sophisticated rocketry, intense scientific and engineering payloads. These teams have spoken with astronauts through the week. They've had a chance to speak to scientists and engineers. They've toured NASA Marshall facilities. They've seen where we're building NASA's next deep space exploration rocket, the Space Launch System. And so you guys have had a great week, culminating with a launch today. And so tell me your name and what year you are in school and what school you attend.
I'm Sam.
What school are you from?
I'm homeschooled, but we're a 4-H team, the D4 Dazzlers.
That is wonderful. Once again, homeschools, 4-H groups. We have a lot of different participation in here. So the D4 Dazzlers, tell me a little bit about your payload. I see you're holding it right here. We talked about how every rocket has to carry some kind of payload, and you guys seem to go with the biological route. And tell our viewers why you chose that.
Well, our payload it carries up the roaches, and then we study them for damage to see how well they survived the acceleration and the G-force. And then also on a different day, it gets left out for 24 hours in freezing weather. And their habitat has heaters and temperature sensors that regulate its temperature.
So how do you guys monitor that data and keep track of that? Is that just hand and using thermometers or computer systems?
We have electronic systems on an electronics board that goes inside the hab, and it detects all the data such as the heat, the humidity, and the battery, and then it sends it over to our computer.
Okay. And so lots of teams, once they've designed and built their rocket, they do tests before they come here to the Space Launch System. You guys find, and we want to talk a little bit about, first tell us your name, please.
My name is Mia, and I go to Cassidy Public Schools in Michigan.
All right, so you guys have tested this rocket before. How did the test versions go?
The test went really well. I had to say that we flew one of them, so she survived.
Okay, awesome. And does this rocket have a nickname? Is there a nickname for your rocket?
We call our rocket RISE, which is an acronym for Roaches in Space Exploration.
I like it, and trust me, at NASA we use plenty of acronyms. In fact, everything we do. And so, are there some people you'd like to thank who helped make it possible for you to be here today? We want to do that?
We'd like to thank NAR, NASA, Orbital ATK, and Tuscaloosa County 4-H.
Okay, we thank all of them as well. We thank you all for joining us today. It's been great having you here. I look forward to seeing you all tonight at the award ceremony. Thanks for coming. We appreciate it.
Thank you.
Excellent. Another opportunity to talk to wonderful kids, students from all around the United States, as we've got rockets on the launch pad. Students are getting them ready right now. We've got another team coming up here. We'll get a chance to talk to them. This is a well-designed, beautiful rocket. It's got a great art scheme all over it. All right, have you launched?
Yeah.
Okay, excellent. So tell me your name, please, and what school you're from.
My name is Jessica Butler, and I'm with the Northern Illinois Homeschool Association.
Okay, excellent. And your name also, please.
I'm Jenna Butler, and I'm also with the Northern Illinois Homeschool Association.
Okay, so tell us a little bit about this rocket. What's it made out of? How heavy is it? How long did it take you all to make?
This rocket is, it's made out of fiberglass. It's about 17 pounds, and it's a kit, so we just assembled it, and it took a few days. Yeah.
Okay. And then you've had to choose some kind of payload. Can you tell us a little bit about the payload you chose?
So the payload we chose to do was a carbon dioxide method of deployment. So instead of using the typical black powder, we used carbon dioxide to blow off our nose cone.
Okay. And one thing we always like to promote and talk about is women in STEM, women who are in the science, technology, engineering, mathematics fields. You guys are a perfect example of being here right now. What's something you want to study when you graduate and finish high school and move on to the college realms?
Just anything that has to do with creating something. I really like having new ideas and being able to see them come to life.
And same question, what do you want to study in the future?
Yeah, same as her, just something probably creative, building stuff, maybe engineering.
Okay. And are you a rookie team? You weren't here last year, is this true? Okay, and if you've seen all these teams throughout the week, what do you think is one of the coolest things you've seen, rocket designs that you've seen? You're like, oh, I would like to try that, or I would like to do that. We should incorporate that in next year. Have you seen anything that's really stood out from any teams?
A lot of the designs that have like modified fins and like seeing that affect their flight is really cool.
Yeah, we've seen carbon fiber fins. We've seen some that have 4 fins, 3 fins. And so looking at your rocket, could you tell us a little bit about the design, the artwork? I've seen some different names on it. Is this artwork and stickers that you guys did? Did it come like that?
Yeah, this is printed vinyl with the names of all of our sponsors.
Okay. And who are some of the people you'd like to thank for being here today?
My family, which would be my dad, who is our mentor, and my mom, who came to support us, as well as the owner of the company that, like all the companies that are on this rocket, Maximator LLC, as well as HR Filtration, and John Ruckel. Thank you.
That's great. We thank them as well, ladies. Congratulations on a successful day. We'll see you at the award ceremony. Awesome. Thanks. Another shining example of women in STEM, something that we're always interested in. We've got teams we mentioned from all across the country, but also from right here in Huntsville, Alabama. We've had local teams, University of Alabama, Huntsville. We've also had Auburn University. And Bill, we got another local stalwart in the house.
Oh, yeah, I had to jump in on this one. Alabama A&M University, you had to pass them to get here. They're actually probably the closest university that are the closest team. Everyone's trading out. Okay. So, all right, come on in. It's okay. You're fine. We'll reveal the rocket here in just a minute. First of all, tell me your name and what year you are in school.
Jalen Jackson. I'm a freshman mechanical engineering major at Alabama A&M University.
All right, Jalen, and your name?
My name is Imani Dash, and I'm a freshman mechanical engineering major at Alabama A&M University.
So it's safe to say you two are rookie teams, or at least you're rookie members.
We're all freshmen. We're an all freshman team.
That is encouraging to see, actually, that you guys will hopefully be able to stick with this for a few years. So, all right, so now part just a little bit, and let's take a look at your rocket. Imani, why don't you start? Tell us a little bit about the design.
So our rocket is made out of blue tube with birchwood fins. It's about 19 pounds, 100 inches in length. We're flying on a K750 motor, and basically we have a dual deployment system.
That's a light motor, a light rocket, I should say. Only 19 pounds?
Yeah, it's really light.
Was that a major consideration when it came to trying to shape some?
As possible, and if needed, we would be able to add weight because it's easier to add weight than take away weight.
Good call. Jalen, can you tell us a little bit about the payload that you chose to go with?
Yes, our payload.
Let me get on this side of you.
Yes, we have the gyro and payload. We have our Arduino down here at the bottom, and we have our 2 fins right here, so it's going to rotate. And we also have we had the Raspberry Pi camera, but we couldn't get it mounted on. But we do have the 3 Raspberry Pis in the cluster inside of our eBay right here. So we have that installed in there along with our 2 altimeters for the 2 mains or the main and the backup.
Now, I noticed you went with a good sleek look, but I couldn't help but notice you got the International Space Station sticker right there.
Yes. We decided to put the A&M sticker and the NASA sticker on the outside just to add a little color to it because we just went with the straight black, so we wanted to put a little bit of color on there.
Looks sleek, though. Looks sleek. So tell me, how did you what was your biggest challenge, I guess, when it came to approaching this design?
Definitely the electronics bay. That's the one piece that always gives us fit on launch day. That's the piece that takes the longest. Sometimes we have wires that missed up trying to get our bulkhead on. That's been really the biggest problem. But next year we know going in to try to be real careful about that and really better with the design because this year it gave us so many problems.
I want to come back over here to Monty. I didn't forget about you. I didn't want you to think I was letting you get away. So how was the testing when you were running this?
Both of our testings were very successful. On our first launch, we got to an altitude of 5,065 feet, but that was way too high, so we want to do 5,070 feet on our second launch, and so hopefully we're hoping to get to that mile mark today.
Okay, are there any sponsors or family members you want to thank, advisors?
Thanks, ART, Alabama Space Grant, and especially the College of Engineering. They helped us out along the way with constructing our rocket, and especially our parents for supporting us throughout the process.
Hang on, let me come down here.
I want to thank Dr. Chan, Dr. Glenn, and the College of Engineering. The College of Engineering all together really helped us out and supported us through the entire process.
All right, well, guys, I want you to give a great big Go Bulldogs right here to the friends and family at home. This is the team from Alabama A&M University.
2, 3, Go Bulldogs!
Nice work. We'll see you guys launch here in just a few minutes. Okay, we do not have another team for you guys right now, but we do have a whole bunch out there on the pads, and we're going to be checking on their launches here in just a few minutes. So we're going to take a short break before we continue. Are we going to take a break now, or we got somebody ready? Okay, we're going to go ahead and take a break. You're watching our live coverage of the 2017 NASA Student Launch Initiative right here in Tony, Alabama.
It's supposed to go both ways. This broken heart is hardly worth the price you didn't pay. Baby, I've been wondering just where you've been since I fell in under your spell. You left me high and dry. Baby, you took my breath and my heart right off my sleeve. You made a fool out of me. Now I'm not sure if this is how it's supposed to be, but I know that my love ain't free. I'm gonna need to be reimbursed, put back together first things first. I'm gonna need a little payback for what you've done to me. Might take a little begging, some pleading, some changing, a little rearranging. Maybe then you'll see. Baby, you took my breath and my heart right off my sleeve. You made a fool out of me. Now I'm not sure if this is how it's supposed to be, but I know that my love ain't say that we're low class. Bunch of rednecks just sitting on our ass. Cars on cinder blocks out in our front yard. Barefoot kids running through the trailer park. Oh, wasn't that all us? Oh, back when we were young and Mama's on her fourth front porch PBR. Sister's getting stoned, Daddy's wasted at the bar. You could judge us and I'd probably agree. It don't look much like the American dream. But oh, to each their own and
Hi, my name is Tammy Statham, and we are live here at the Student Launch Challenge. I'm with ETA Academy at Roosevelt High School, and they just launched the rocket. Would anyone like to tell us how it went?
Hi, I'm Anna, the team captain. So far, it had a mostly successful launch. Our experiment was executed perfectly, although our main parachute did not deploy successfully.
Well, it seemed to hold up very well despite that, so congratulations, guys. Did you have any design challenges when you, throughout the last year or so that you were designing this?
Most indefinitely. It was pretty difficult at the start because we didn't know much all about rocketry. All we had come from was model rocketry in the past and whatever previous experience we had back in middle school. And so we definitely had to go through many trials of RockSim. I can tell you there are dozens of files where we're you can see from the beginning it was little and then we expanded to this size. So.
Absolutely. I'm sure it's a great experience for any of you about to go into college now, too, because you already have this wonderful hands-on technical experience. Who's a senior here? Oh, really? Are you guys going to college in engineering?
Yes, actually, I'm going to UTSA and getting my PhD in genetic engineering and then a master's in biochemical engineering.
That sounds great.
I'm going to UTSA for software development, so not really in the field of rocketry, but you know.
Well, there's lots of technical fields that go into rocketry. We have plenty of software engineers working on SLS right now, so you can certainly stay in the industry. I want to ask you about your design. This is beautiful. How did you guys create this? Is this you?
What I did was first I had to fill in the lines because Bluetooth naturally comes with lines inside of it using wood filler. And then we primed it with the black. And then I used an airbrush and a small paintbrush, a fine tip paintbrush, to do details and the shapes.
And my last question for you guys is, I'm sure you've gotten a lot of support from advisors, mentors, maybe some sponsors. Is there anyone specifically you'd like to thank for this?
Actually, Miss Thomas, right? Yeah. Actually, I would like to thank my middle school teacher, Miss Thomas, for she's the one who introduced us all. Most of us went to KSAT, and also Miss Moreno has been a huge help. She was our
engineering
advisor.
Teacher. Yes, and she's also one of our mentors. And then also, I'd like to thank my parents, my mom, my stepdad, and my dad for all supporting us and helping us to be where we are today.
Well, congratulations on your launch, guys, and we hope to see you here next year. Thank you.
See you guys then.
I'm live here at the Student Launch Challenge with the team from Iowa State University. Would you mind please introducing yourself and telling us your major?
Hello, my name is Austin Kaiser. I'm the project lead for Iowa State University, and my major is aerospace engineering.
Great, and could you tell us a little bit about the payload that your rocket has today?
Yeah, so we chose the roll induction design. That's one of the three main payloads for NASA. Basically, we'll be rotating our fins to induce two rolls for our rocket on its ascent way up. then it'll counter-react and halt all rotation for the ascent. So.
Great. And what data are you going to be receiving live from the launch, and what data are you going to be looking at after the launch?
Yeah, so we have an accelerometer on board. We'll be looking at that. We also have an onboard barometric pressure sensor, along with our 2 altimeters. So we'll be looking at all of that data along with some video on board. So we'll get that for you.
Oh, that's great. Well, I'm wishing a lot of luck to you guys. This is really exciting. I'm sure it's a lot of work culminating all at this one time. So, is there anyone specifically you want to thank for getting you here today? Advisors, mentors, any sponsors?
Yeah, I'd love to thank Iowa State University, especially the Make to Innovate program. They've been a huge help for us, especially the Iowa Space Grant Consortium, our mentor Gary Stroik, and especially Mako in Clive, Iowa. They were the ones who painted our rocket, who gave us a nice paint job. So thank you.
How many of you guys are seniors? Any seniors? Oh, okay. So you guys are all going to come back next year, right? And have an even better rocket, right? Awesome. Well, best of luck to you guys. And thank you.
Heard a honk from the drive. It was a truck I didn't recognize. The next thing I saw was a suitcase and spinning tires. And they were gone in a cloud of dust. Guess it was sayonara. Now that was harsh, so harsh. No, this heart ain't ever been the same. Cruel, a real cruel girl. Ain't no recovering from the pain. Well, if you have to say goodbye, well, why'd you have to do it so damn sly? 'Cause that was harsh, so harsh, girl. Like a little smoke, smoke, smoke with no high. Yeah, I thought something was off. She'd been smiling a whole lot more, and I knew that wasn't my fault. She ain't been that happy before, but I never thought she'd leave in a stranger's passenger seat. That was harsh, so harsh. No, this heart ain't ever been the same. Cruel, a real cruel girl. Ain't no recovering from the pain. Well, if you have to say goodbye, well, why'd you have to do it so damn sly? 'Cause that was harsh, a real harsh girl. Like a little smoke, smoke, smoke with no high. That was harsh, so harsh. Now that was harsh, so harsh. No, this heart ain't ever been the same. Cruel, a real cruel girl. Ain't no recovering from the pain. Well, if you had to say goodbye, well, why'd you have to do it so damn sly? 'Cause that was harsh, so harsh, girl. Like a little smoke, smoke, smoke with no.
It's a key fob with the unlock and the sound, the horn. It was found near the Hera trailer by the trailer hitch, and it's not.
they wrote the book. See, they're the next big thing. They're living the dream. They cast the line and got the world on a hook. But it's not reality, just the real they want you to see. Cut in half truths and tall tales.
It's going to be a higher main deployment as well. This is going to descend into 3 separate sections at 1,200 feet. So we want everybody's eyes on that. 81, sky is clear. Range is clear. 81 in 5, 4, 3, 2, 1, start. There's the up part looking good. It's cruising on up, chugging along like an Energizer bunny. There's the delay trail. There's the arc over. We're looking for the event. There's an event charge. We see a shoot deploy. We've got a device under a drogue, and we've got a large parachute at the top. And there's another device. So we've got 3 items up there on chutes, folks. I want everybody's eye on all 3 items. The bottom one we're assuming is the lander. It looks like a lander. Nope, that's the rocket body. Yeah, the rocket body's tumbling on the drogue in a safe spin out in the safe landing area. So we got 2 colorful multicolor chutes out there in a hot thermal sky. There's the 1,200 main on the booster. Dust Devil behind the flight line. Watch out for the Dust Devil. Taz, we told you to stay home. I guess he's looking for a wascally rabbit. Wow! In Kansas, they call that a white tornado. Ajax cleanser will clean like a white tornado. Yeah. Okay. We're going to move to the next rocket since we've got consensus that those parachutes are going to come down safe after a while. On pad 61, Auburn University. They all came in and all needed prior stuff. This is 61, Loki 930. We heard their shouts in the back, so obviously they're ready. Pad 61, everybody take a look at it and point to the rockets as you see them. In 5, 4, 3, 2, 1, start. He's pushing the button very hard. A nice thunder out of the nozzle of that rocket. Low key motor. There's the arc over. Looking for an event. There's the charge. We've got the drogues coming out. Okay, we're going to put some spotters on that rocket. Okay, that one's going to recover out in the safe area. We're going to put 2 spotters on that and move to pad 62. Vanderbilt Aerospace Design Labs. Roll control with gas thrusters. This is a really cool rocket, folks, if you've seen the gas thrusters controls at that the trade show rocket fair. Loki 1400 should have some noise. Rocket name is High Roller on pad 62, going in 5, 4, 3, 2, 1, start. Nice thunder roar. It's coming over the head of the flight line. Everybody heads up and look at it. Look at it. It's still going. Still going. Arcing over. There's the eject. I see the drogue. It's coming down now. We can see the smoke charge through the last smoke. Vanderbilt's up there at about 3,000 feet right now, right down the roadway to the south. White drogue, nice looking rocket up there in the sky, about 2,300 feet. And it's going to pop a main at 700. 15 or 12-ish right about there is my guess is where it's at. We're looking for 700 feet. That's about 900, 800. 700 would be about 3, 2, 1. There we go. There's their main. There's the rocket. Wowzer. Next, we take our attention to pad 60. The Piedmont Student Launch Team. Are you ready? Roll induction is on this rocket. Everybody have a good look at this rocket and point to it as it flies. It's an L1150 pad 60. Going in 5, 4, 3, 2, 1, start. He's pushing the button hard. Got an open, there it goes! Red motor. It's cruising up. It's over the LCO's head right now. It's arced over the flight line. I want everybody pointing on the trail here. It's behind the flight line. I want everybody watching this rocket. We have a drogue chute on it. We're looking for any other pieces coming down. None confirmed. Looks like it's coming as it should. Okay, it's now south of the flight line. We're still keeping a good eye on it. The winds can change aloft. Everybody point at the rocket if they see it so others that can't know where it's at. This is going to go to 800 feet for the main, and there's it at. Yeah, we got to get back in the swing of things like this again. Next up on pad 10 is Fighting Irish. Akron, Ohio, Tumbler. Continuous CO2 gas sampling. It's another roller with a Cicerone K600. Well, they're from Ohio. Give a shout for Ohio, folks. Pad 10. Pad 10 going in 5, 4, 3, 2, 1, start. It's cruising on high. It's over to the east of the road. So let's keep an eye on this. It's on the east side. It's still cruising. Just starting to arc over now. An event at the arc. I see two body tubes sparkling in the sky. The rocket does have an orange drogue on it. We've got reports of. This is going to have a main at 600 feet. Looking for a main, it's about 800, 700, 600. Let's look at pad 20, the Newport Rocketry Club, Delaware, Washington. This has a Jolly Logic chute release and is going to fly on an K820 Cicerone. Skies clear, going in 5, 4, 3, 2, 1, start. Great boost up. Again, this one's going over to the east. We did have a small wind change, and that's probably why. It's arcing over. Looking for the event. The event. Looking for the event. Okay, heads up. It's backsliding. Heads up, because it could slide towards us. It's in a flat spin. Where's it at? Okay. We've got the body tube coming in a flat spin, what we commonly call backsliding, similar to a lifting body on a shuttle-like space vehicle. Without the top part of the rocket, the body tube actually generates some lift, and they call that backsliding. There is a technical paper on that on the internet that you can look up, backslider. It's at about 300 feet. There we go. I can't lift my head back anymore. Let's look at pad 21 now. Ingram High School, Seattle. Rocket name is Shock Sand. Testing different methods of acceleration and shock loads. On a CTI K500, skies clear, going in 5, 4, 3, 2, 1, start. It's about right over our heads. It's now a little bit over the flight line. Still going straight up. It's moved a little bit south. It's arcing over. There's an event. There is a drogue out. This will have a main at 600 feet, which should be about now. Testing. adjusted the volume level down. I don't
We're going to go with pad 22 next.
Cedar Park Homeschool. Pad 22. Rocket names Venus on a CTI K600. This is using magnetic levitation to dampen G-forces, not to make it go up. Okay, pad 22. 5, 4, 3, 2, 1, start. Roars up. Arcing over. There's an event. We're looking for confirmation of a drogue. I do see a sparkling body tube. We have confirmation of the drogue. Okay, I can't look up there anymore. I can't. It's been hurt for the last 2 hours. I'll call it now. It's going to go at 900.
About 2,500 feet.
2,100 feet. About 1,000-ish. And there's the main. Pad 42, K480. Team USA, the Iron Eagle. This is a roll control payload. Let's watch this rocket, folks. Oh, we have a hold. We have an aircraft in the area from our aircraft spotters. We need to really, there's a lot of effort put in an entire team here. It's just, it just isn't one man on a microphone. We've got air spotters, we've got field spotters, we've got the pad managers all together working as one National Association of Rocketry team. Without their help, none of this would happen. Okay, we're giving a look to make sure the sky is clear here again on pad 42. Team USA will fly on pad 42 again on a K480 white motor. This is a roll control payload with servo-controlled roll fins. On 5, 4, 3, 2, 1, start. Nice straight boost to the west. It's arcing over a little to the south and now going to arc over the flight line a little to the west. Let's everybody look at it. It's still arcing over. There's an event charge. There appears to be an orange drogue chute. I see sparkling body sections like they should be. And it looks like it's at about 3,800 right now. This one will have a main at 700.
rolling through 2,000.
It's about 2,000-ish level. Again, we're looking for 700. About 15, 12, 9, 8, 7. There's the chute. Next up on pad 51, UND Frozen Fury, L1500 Blue Thunder. This is going to have roll induction, and at 1,000 feet, we'll separate into two separate sections. So we'll have to watch those two separate sections at 1,000 feet. Skies clear, range clear, pad 51. 5, 4, 3, 2, 1, start. Super Thunder. And there it goes, cruising. Cruising on the boost from the momentum of the acceleration. Arcing over. Now we need to see an event charge. I see one. I have reports of a drogue. I can see the sparkling body tubes. It's at about 3,000 feet right now, off to the west. $2,000. $12-ish. Oh, there we go. There's 1,000. Next one. You had it dead on the money, Greg.
10,000.
See? Getting rubs off on you.
What are we at? 80?
Pad 80.
Pad 80 next.
This is Mr. Twister. 2 sets of extruded airfoils provide through the rocket, powered by 2 cam systems. Okay, so this is a roll control project on a Aerotech L1000. It's going to deploy at 700 feet, pad 80. 5, 4, 3, 2, 1, start. There's the motor burn. It coasts in the momentum. Following the tracking smoke. Darking over. There's the event charge. And the body frame sections are sparkling in the sun. Sometimes we call that doing the dance. The 2 body sections will dance around each other, attached by the nylon or Kevlar recovery harness. Rocket appears to be doing the dance correctly. And I can't look up anymore. I'm afraid to not look up while it hasn't come into 2 sections. It's going to go at 700. Where's it at now? Right there. There's the main. And when it hits the ground, we can open the range, correct? Look at the chute spin on its snap swivel. And it's down. Range is now safe for recovery and racking of rockets.
Joined now by another one of the teams that is going to be headed out there to launch our rockets in just a few minutes. North Carolina State University is joining us, and this is Emily. She's their, I guess, team lead. Is that appropriate?
Yes, I'm the team lead.
Okay, so you guys have been here many years. First of all, let me ask that. How many seniors here? Have you've all been participated in previous years?
I've been the only senior that's participated in previous years. I kind of brought them along with me.
All right, so tell us about the process from when you were a freshman or earlier starting on this to the rocket you decided to come up with today.
So freshman year I joined the club and it was a whole lot of fun, and it just kept being fun. And then it's our senior design project, so I just sort of picked names out of a hat and asked around anyone that wanted to join me, and I got 4 volunteers.
All right, so what about this design for this rocket? Did you kind of collaborate with the other team members, or surely you didn't come up with this by yourself?
Oh, no, I didn't come up with this by myself. We definitely spent a couple months collaborating on this. All of August, all of September. I was kind of out of the picture because I was in a car accident. But so they worked a whole lot on it. So it's really their baby coming to life, and I'm just yelling at them.
As team leads do. No, I'm kidding. But so yeah, you guys have a great, big, huge team here. So tell us a little bit about this. Who wants to talk about this particular design? How you arrived at this design as far as the guts and such?
So the dimensions of this rocket are primarily driven by our payload. We chose the target detection and upright landing system. So what we have is a payload in here, a little 4-inch cylinder that's all clear, and it's driven by a Raspberry Pi microcontroller that's taking pictures on the way down. And when it comes down, it lands, doesn't matter which orientation, it has legs that expand and landed upright. And that's really what we were trying to accomplish with this rocket. Picking one of the more challenging challenges.
Oh, sure, yeah. For those of you at home who are just joining us, there were 3 challenges that some of the teams could select from. One of them was trying to keep safe an undisclosed until this morning item. Turns out it was like one of those small clay pigeons you find at a target range. Another one was, of course, the targeting or location.
Target detection and upright landing.
Cool. All right. So that one as well, and that's the one you guys selected. I'm sorry?
The roll control was the other one, if you wanted to.
Thank you. Yes, the roll control meeting with one spin's going up. It's to help stabilize it on the way up. It's been a long day for all of us guys. So, okay. So what have you learned in doing this project now, especially as a senior, that you think you're going to be able to take on as you move into your future endeavors?
Definitely just being able to work with people as a freshman and a sophomore and a junior. It was a lot of fun just getting all the hands-on experience and the technical writing experience. But as a senior, and this being our final project, there was a lot more teamwork involved and patience and speaking up that I wasn't really comfortable with until now.
Well, then I won't ask you to do it for too much longer, but what is the official name of your rocket?
Our official name is Vesuvius. I think it's on a fin down there, very tiny, but it's cute.
Hoping to get an eruption?
A safe one.
So, and you're still called Taco Lycos, right?
We definitely are.
Okay, tell everybody at home what that means.
It means Speedy Wolf.
And why would you possibly be known as Speedy Wolf?
Because we like to go fast.
Hopefully it'll go fast, straight up, and come close to 1 mile. The team from North Carolina State University. Say it to everybody back home, guys. Friends, family. They'll be up next here in just a few minutes on the 2017 edition of NASA Student Launch.
All right, we're continuing live coverage of the student launch event. We're joined by another team that comes here year after year. Citrus College is in the house, looking excited, ready to get the rocket off the ground. Would you please tell me your name, what year you are in school, what you're studying?
Hi, my name is Yvonne. It's my last year at Citrus College. I'm currently studying mechanical engineering. As far as our rocket, it is 119 inches in length, so approximately 10 feet. It does weigh 45 pounds currently, and it's made out of blue tube, and we did find the fiberglassing ourselves.
All right, so 45 pounds. We talked about one earlier. It was 50, and another team that had a 14-pound rocket. The weight, is that something you wanted to increase or decrease?
Well, in the forward, we have our payload, which is actually pretty heavy. So we wanted to increase it to stabilize it. So that's why we did the swapping, and then we put the main parachute in the center to also keep more weight in the forward section. So we kept the drogue in the back to keep it light because the motor itself is already 10 pounds.
All right, so you got a 10-pound motor. Center of gravity is always important on these rockets. One thing is you mentioned this is your last year at Citrus College. How many people have been on the team in years past? You should raise your hand. You guys are all rookies. So the school isn't a rookie school at Student Launch, but you guys are. This is your first year here. Well, awesome. Let me be one of the first people to welcome you to the great state of Alabama. Wonderful. And so now we talked about the payloads. Each rocket has its payload. I'd like to hear some more about that, sir. What's your name?
I'm Jimmy Lopez. It's also my last year at Citrus College, and I'm also studying mechanical engineering. Our payload, we chose to go with the fragile material protection because we wanted to take on the challenge of being able to create a container that could protect an unknown material before, during, and after flight.
Okay. That was one of the design challenges, and it seems like you chose that. I think that's a great job. Does your rocket have a nickname? Is there a nickname for your rocket by chance?
Our nickname for our rocket is Aladay.
Okay, and why?
It just comes out of our favorite characters from a TV series that we all watch together while, working on our paper together.
Okay, excellent. I like that. That's wonderful. And so, obviously, there's a lot of work that goes on to get these students here year after year. You guys are from California, so not only all the work you have to do, but then it's the distance and the travel. You're not only worrying about basically logistics for students, but you also have to get the rocket here as well. And you don't do that on your own. It takes a lot of help. And so, if you two could turn around for us, please. Let me see the back of your shirts. And you could actually just tell us some of the people they'd like to thank for helping them be here today.
All right. I'd like to thank the California Space Grant Consortium, Citrus College Foundation, Citrus College Natural and Physical Sciences, Citrus College Race to STEM, Citrus College Visual and Performing Arts, Glendora Educational Foundation, MAA Tensor Foundation, Poplar International Incorporated, Martin Gunderson, Rosalinda and Leigh Butchweld, and Timothy Ferguson.
All right, that's a lot of people, and that's because it takes a lot to get you guys here. We'll want to wish you good luck on your launch in just a little bit, and we'll see you at the award ceremony. Thanks. Appreciate it. Good luck. All right. Awesome job. We'll bring in some others. Oh, excellent. We got another high school coming in. All right. You guys can go that way. Thank you very much. Once again, we are streaming live on Student Launch Facebook page. And if you'd like to keep track, you can go to the Facebook page, engage, share, like, comment, retweet on our Student Launch Twitter account. The hashtag is #Student Launch. We keep it basic and keep it simple, but it's a great way for you, the viewers at home, and all around the world watching on NASA TV, on NASA Marshall Ustream, Twitch, as well as Facebook Live to ask questions. We have an A staff of social media experts that join us every day. We're always constantly trying to get online digital. And so that being said, let's talk a little bit about your spokesperson.
Yes.
Yes, tell me your name, what year you are in school.
I'm Jacob Rappaport. I'm a high school sophomore from Ingram High School in Seattle, Washington.
Ingram High School, Seattle, Washington. That's a long way. You guys have already launched. Tell me, was your launch a success?
Yes, it was.
Tell me a little bit about it.
So we went to...
Okay, excellent. What's your name, sir?
I have the flight data. So we flew to about 5,099 feet. Unlike last year, our main actually inflated this time. It went on the backup charge. I'd like to give a shout out to University of Alabama, Huntsville, because they loaned us their backup altimeter, which enabled us to make that flight possible.
Awesome. Great. So a little bit of camaraderie going on that helps to the Team Spirit Award. Once again, high school teams get a chance to learn from the college teams as well. Who else has something like to say about the rocket? How about what it's made out of, the design material? Who can talk about the rocket? All right, tell me, what's your name, sir?
My name is Samuel Waring.
All right, so tell me, what's the rocket made out of? What does it weigh? How long did it take you all to build it and all that good stuff?
Okay, so the rocket is made out of fiberglass and coated with black paint, clearly. So Let's see. Okay, so it weighs approximately 17 pounds with the motor inside of it. Without the motor, it weighs closer to 14. We were using a K500. We started building this in December, and it took us until our test launch, which was when was it? February. Okay. However, we did continue to make improvements on it after that, including the paint job, which was not present at that point in time.
All right, excellent. That's a lot of great people, I think, makes this happen, as we saw some our previous schools. And I think you guys might have some information on the back of one of your T-shirts. Who's got a T-shirt on that's got some kind of design content on the back here? Once again, it's a chance to show the hard work that these students do. Oh, excellent. We want to read the quote for our viewers at home, please.
If you turn around. The difference between screwing around in science is writing it down by Adam Savage.
Keeping track of all your content, everything you worked on. It seems like you've had a great, successful launch and a great day. It's wonderful having you all here, and I look forward to seeing you at the award ceremony as well as seeing you all next year. Thanks. Wonderful. I appreciate it, guys.
Thanks so much.
All right. Awesome. So we've done a great job. Once again, we talked about all the different variables that these students are working on throughout the year to design science, technology, engineering, math, all that engineering, but it's also the logistics, website design, marketing, fundraising. So these students really work on a lot of content. And this is just one opportunity of several opportunities. We mentioned earlier today, last week we had the Human Exploration Rover Challenge, which is another competition for high school and college students. Student launch being this our 14th year. And there are several NASA opportunities. We've got two special guests joining us, both from Kennedy Space Center. Is this true? I know Rob is for sure. Rob is a good friend of mine when I used to work at the Kennedy Space Center. So I'll let them introduce themselves and tell us a little bit about your programs.
Rob Cannon. I'm the activity manager for the First Nations Launch Program.
And I'm Christine Thompson with Wisconsin Space Grant Consortium, and I am the program manager for the First Nations Launch.
Okay, so First Nations Launch is what we're talking about, but what is that?
So First Nations Launch is the largest Native American rocket launch for undergraduate students in America. We have approximately 16 teams coming this year from 15 different schools and 11 states from around the country. And so they're coming from tribal colleges, and they're also coming from different universities throughout the United States, teams that are associated with the American Indian Science Engineering Society.
All right, so 15 teams, 16 schools, is that right?
16.
I did it backwards. And they're going to be launching at?
Up in Kansasville, Wisconsin.
Okay.
So, April 22nd.
Right, so April 22nd, we get a chance to see this launch. Tell me just a little bit about that. Do they have engineering design challenges? Is it an altitude competition?
So it's actually broken up into two. So the Tribal College challenge is going to be to have a dual deploy rocket with no larger than a J motor, and the students are going to have to,
So it's a stability challenge. It's a stability challenge and with no roll at an XYZ axis.
And have you guys, how many years has this taken place, or will this be the first year?
This will be our 8th year, and then we have the tribal competition, and then we have the ACES competition. The ACES competition is going to deploy an active draft system on a second launch, trying to get to 75% of their apogee.
Wow. Okay, so it's a great opportunity to reach out and do STEM with, as we've got teams coming, going very excited day to day. All right, so talking First Nations launch, April 21st, I think we said April 22nd. And who all is helping make this possible besides NASA and the Wisconsin Space Grant? Is it just the two?
And we work with the National Space Grant Foundation as well.
Okay, excellent.
And Carthage College.
So if people wanted to find out more about this and getting involved, it might be too late to register this year, obviously, since April 21st, 22nd is just around the corner. How would they get involved in this going in next year and get some more information?
Go to our website, which is spacegrant.carthage.edu. And we have information under the First Nations launch, and you'll get tons of information there.
You guys social media channels?
Yep, it is going to we're on Facebook, Wisconsin Space Grant Consortium, and we have the information on there.
That is wonderful information. I really appreciate it. Good to see you again, Rob. I'll see you the rest of the day. Thank you, Christine. We appreciate it. Wonderful opportunity, more outreach, more educational opportunities. So we got teams coming everywhere once again. I think we got a team ready to come in here right now. Gentlemen, you want to join us?
Yeah, this is
awesome.
Ole Miss. I think we recognize these guys.
Ole Miss.
We got rockets coming, rockets going as they're getting recovered. Now, this is kind of a unique chance on this one, folks. As you know, we spent a lot of time talking about the length of the program and how many people pick it up and started in August and September and work so hard to get here to launch. But every now and again, as you test it, something happens that you're not quite able to fix. And that is kind of what happened to Ole Miss here. First of all, sir, tell me your name.
Dylan Hall.
Okay, Dylan, and what year are you in school?
I'm a junior.
All right, so Dylan, you went through the whole process, documented everything, I's dotted, T's crossed. But what happened?
So on our second test flight, we had a small problem when we had reached apogee. The shock cord had a failure, and one of the loops had come undone. And so that meant that our fin can had come detached from the rocket and didn't have a parachute on it. As you can imagine, that had some consequences and from free falling from a mile. And so we had a lot of damage on that section. So we had to rebuild it and had to find a launch site that could facilitate us after we fixed it. And we just couldn't make that deadline. So
it's a matter of, again, one of the requirements is making sure you're able to actually test fly multiple times before you bring it down here. So I'm glad you still made it, because this is one of those, I guess, learning opportunities, even though you don't quite get to see it fly here, but you've gotten to see it fly back home. So go ahead and tell us a little bit about your design.
So we were really trying to stress additive manufacturing in our design. We tried to make everything in shop, use all the equipment and machines that we had available to us at Ole Miss. And so for our airframe, we did an in-house carbon fiber layup and made this ourselves, cured it in our own oven that was in the factory. And and outside of the airframe, almost everything else is 3D printed. This nose cone is 3D printed. The avionics sled is 3D printed, and a lot of the sections in the fin can are actually 3D printed, like the fins and the fin sleeve, centering rings. Pretty much the only thing that isn't using additive manufacturing is the steel attachment bolts. So I think we made a really good design, and we know it flies really well. And so, yeah.
So were you going to tell us about the avionics sled?
Yeah, so it's
let me go and grab that for you.
We have a carbon fiber base here, bulkhead here. What sort of plastic was it? ASA plastic. And so, it allowed us to create something that was, really unique, maybe harder to create with something else, some other material.
We could really tailor it to our design and configure it exactly how we needed it.
Going straight from the computer to manufacturing. All right, there you go. So what payload did you guys decide to go with of the three options that were given to you?
So we did the fragile protection apparatus, fragile material protection apparatus. Basically, it's kind of the same concept as a car suspension, where you use a combination of air dampers and springs in a system that is holding an inner capsule. And so just for a little bit of extra protection, we filled that capsule with some packing peanuts just to give it a little protection. That capsule has a screw on top. So even though the whole system is epoxied into the payload bay, we can still access the cargo and insert and take out whatever we need.
So a little shock absorber on the inside, and then able to make that kind of adjustment. Really quickly, what are you guys studying in college?
We're all doing mechanical engineering, and that's one thing is that Ole Miss doesn't have an aerospace engineering program yet, so we are just holding it down with mechanical for now.
Okay, I think the gauntlet has been thrown. Ole Miss, aerospace engineering. What do you think you guys have learned from this that you're going to be able to take on to your future endeavors?
So probably the biggest thing is taking a paper design and turning it into an actual realistic product. And not only that, figuring out what manufacturing constraints you have, what we can and can't do, what one little change can do to the entire flight of this rocket. And so through making it and through the failures we may have had in our test flights and stuff like that, we were able to really get a good real-world engineering problem and have the chance to fix it. So.
Yeah, and it's our first year, so while we may not have been able to test flight this and end up launching the competition, we're definitely proud of how it ended out and our test flights that were successful for the most part.
So you think you guys are going to be able to get some of your maybe some underclassmen to come jump in and join the team?
I am an underclassman. I'm actually a freshman. I'm the only one that actually came, but there are at least 3 other freshmen besides me. And I already know that I recruited one of my freshman classmates this year to join next year. So, we do hope to start picking up other underclassmen as well as keep a hold of our upperclassmen to help.
We'll be able to see you out here next year, right?
Yes, most likely.
Absolutely.
And hopefully next year they'll get a chance to fly. The team from Ole Miss, guys, we're so glad you can make it out here, even to bring, so we can at least be able to lay eyes on your pretty rocket here, and we'll definitely see you back here next year.
Appreciate it.
All right, say hi to all the friends and family back home who are watching.
Howdy.
Thanks, guys. Have you got the team ready to go? Hotty toddy, yeah.
That's SEC for you.
SEC. Let's bring these guys in here. Now, this is kind of
Absolutely.
an interesting case, Chris. It's a team of two, but they still were able to create their rocket and fly it.
Absolutely. So, gentlemen, come on in here, get a little closer together. Once again, just the amazement of science here. We've seen large-scale teams, 8, 9, 10. NC State had like 3 rows. We got 2 people right here, and a high school student and a middle school student as well. So first, tell me your name and what school you represent.
Josh Thayer, and we're with Cedar Park Homeschool.
And your name, please?
Ryan Ragland.
All right, so Cedar Park High School, 2 people working together independently. I talked to a lot of people, and you literally said you guys have done all this work by yourself. We are all amazed and impressed by that. So tell me first, let's talk a little bit about the rockets. Tell me what the rocket's made of, and how did you guys decide this design?
So we started with basically there was fiberglass. All of it, it's all fiberglass, coated in the fins are coated in carbon fiber, and then about 4 layers of epoxy so they can't move. So those aren't going anywhere. And then all the interior, everything inside is made out of fiberglass as well. Kevlar cords, all that.
Kevlar.
Yes, sir.
And you want to tell us a little bit about the payload?
Sure. All right, so the payload that we chose is using magnetic levitation to dampen the effects of G-forces. So inside our nose cone here, we have 2 fiberglass tubes, one that slides inside the other one, and both of them have magnets on the top and bottom so that the inside tube free floats back and forth. And then we have an accelerometer on the inside and the outside tube to measure the acceleration differences on them.
Have you had a chance to download that data yet?
No, we have not.
I'm sure that's going to be part of your report, though, for the future. Let me ask you, how did you hear about this project?
We were in TARC last year, and we made it to nationals, and we're 7th place, I believe. Yes, and the top 24 get invited to here.
So it's just the 2 of you finishing 7th at TARC.
There were 3 of us, but one of us quit, so.
So what do you think you're getting out of this kind of a challenge, though? Even it's got to be a lot of work for the 2 of you to do.
Mm-hmm. Yes, I think it just teaches us a lot about how to go through with the project and build stuff and what rocketry is like.
You think this is something you're going to pursue in the future?
Probably.
Okay. Same question for you, Josh.
Yes, sir. I definitely think the engineering field is very interesting and something I'd be interested in.
All right, so who are some people you'd like to thank? Obviously, thank yourselves, because you guys did a lot of work, just the 2 of you. But yeah, who are some people you'd like to thank to help you get here today?
I would like to thank our sponsors, the Capstone Works IT company and the Wax Shack down in Austin. Okay. And Jim Jarvis, our mentor, he was great. Couldn't have done it without him. So that was great. Our parents are the ones that brought us here, so I'd like to thank them. And I'd like to thank him for building the rocket with me.
Yeah. High five. All right. Excellent work. Congratulations on everything you've done, and good luck. We'll see you guys at the awards ceremony. That is super duper, man. 2 people doing it all by themselves.
Nice work, guys.
Let you talk.
All right, so let's see. I think is that our last team for a moment? Oh, okay. We got some replays coming up. So you're going to see a few of the launches here, and we'll be back with more coverage from student launch right after this.
That's cool. Replays, man. Awesome.
You're watching our live coverage of NASA student launch from Tony, Alabama, just a few short miles from the Marshall Space Flight Center, where teams from high schools and colleges around the country have gathered to finally do the test launches of their rockets that they have, in fact, tested at home. But this is where the rubber meets the road. It's been a long day. And no rocket challenge would be complete without the University of Toledo, the Rockets. Joining us, gentlemen, congratulations on a successful flight. Welcome. So first of all, Michael, tell us a little bit about your rocket.
So this is Cairo. We're doing the active roll control payload. So we have 4 sets of fins up on the rocket that control the roll. We do 2 spins on the ascent and then reverse it. Unfortunately, it didn't activate during the flight today, but we got good data from it, so lesson learned.
I know it's a little early to speculate, but do you have an idea what may have gone wrong?
I'm not sure, actually, so we're going to keep looking into it.
Fair enough. Okay, so you had a successful flight, though. You feel pretty good about it. So tell me a little bit about the actual design. How did all this come together?
So we focused on simplicity and safety. So we're using a single servo to control all fins. So if there is a failure, it fails uniformly and fails safely. We also focus on simplicity. So it's a fairly simple drivetrain. Everything's compact and all located together instead of spread out along the rocket.
You want to tell us who are some of the sponsors or advisors you had back home that you want to give thanks to?
Sure. So we'd love to thank Marathon, the University of Toledo Mine Department, Genius Garage, Pilkington, SolidWorks, and of course our mentors, Art Upton right over here, the LCO, and our advisor back at school, Dr. Sheng.
An artist is intimately familiar with this competition, so it made sense that he was able to get you guys out here. So let me ask, how many are seniors? How many seniors you got there? Just a couple? Two or three? What majors do we have over here?
I'm a chemical engineering student.
Chemical engineering.
Yes, sir.
So did you have anything? Did you work on the rocket side of it or the engine side of it?
No, I was actually recovery.
Oh, recovery. Okay. So why did you decide to join the team?
Well, what isn't interesting about rocketry? So it was something that was just starting up, and I already knew a couple of the founding members. So I joined last year. Had the opportunity to come down last year, and love to join again today.
Excellent. I know we got the software lead over there. What's your major, sir?
Electrical and mechanical engineer.
Electrical and mechanical.
Yes, sir.
All right. So how was the experience for you?
It was great. Yeah, definitely fun spending 8 months and seeing it all come to culmination right here. Yeah.
I know we got one more back there. What was your major? Yeah.
Mechanical engineer.
Another mechanical engineer. Is everyone pretty much mechanical engineers, or
Yeah.
more or less?
More or less. Yeah.
Awesome. Well, you guys got obviously recruited a great team here. I see one missing part is that you don't have any ladies on your team, guys.
We're trying.
I think Art would agree. You need to try harder. I'm teasing you, of course. Well, guys, congratulations on a great flight. We're glad you guys were able to make it out here, and best of luck to those who are graduating, and hopefully we'll see the rest of you here next time, okay?
Thank you.
All right, the team from the University of Toledo, the Rockets, joining us here at the student launch event. Thanks, guys. We're going to ask you to take a big step back because we've got another team with another large rocket coming this way.
Thank you.
Come on up. Oh, Cal Poly. Okay, cool. Welcome, gang. We're glad you were able to make it up here.
Appreciate it.
From Pomona, is that right?
That's right. Cal Poly Pomona.
The Broncos?
That's us.
Fantastic. Oh, you already have your thanks right out here. That's including Uncle Lucky. Okay. All right. So who is your spokesperson? Do you have one in particular?
Sam is our team lead.
All right, Sam, you've been drafted.
Yep, that's the team lead.
All right. So why don't you tell us a little bit about your rocket?
Okay, sure. So our rocket is about 105 inches long, 45 pounds. We're doing our primary payload would be the roll induction system. So if you look at the bottom, you can actually see that we have ailerons that are controlled by a control system in one of our electronics packages. And we actually have 2 payloads. So in addition to our primary payload, we're doing a fragile material protection. So we've put the little ski discs inside a little 3D printed pill that we've made.
So you bunch of overachievers decided to do 2 of the challenges. That's cool. Tell us about this. What you say you 3D printed the case for this?
Yeah, actually, we use 3D printers a lot. Our nose cone, all of our fins, and pretty much the entire body of our fragile material payload is 3D printed. It's a really, it's a cheap way to get nice materials exactly the way you want them. So 3D printing is a great way to go about it.
Test it and quickly remanufacture it. I want to come down here and take a look at the parts that you said. Now, this is what controls the roll down here? Just these little pieces?
No, these are the...
Oh, okay, these. Okay, thank you. I saw that. I was like, wait, okay, that's... Gotcha.
Yeah, these are our ailerons right here that control the roll. So we've got 2 of them on opposite sides. That'll control the roll of the rocket after the main engine cut off.
Okay, thank you, Christian. So after an early look at how all the material came through, do you have any data from those two payloads? How did they perform?
Yeah, actually, so we have a data collection system that picks up on our axial acceleration and our rotation about the longitudinal axis of the rocket. As far as our fragile material protection payload goes, we don't have any quantitative data, but we can qualitatively, open the pill and see whether or not our payloads have broken.
You have not flown, correct?
We've test flown, but we haven't flown yet today.
That's what I meant today. Okay, so you have. Yeah, was anybody nervous?
A little bit. A little bit, yeah. It's our payload, our roll induction system worked really well. Our first test. This time around, though, we have a separate component of it. It's a closed loop, which is a little bit more sophisticated. So it's going to be its first time flying today, so we're a little bit nervous about that. But from the testing we've done, we feel pretty good about it.
Awesome. I couldn't help but notice, by the way, that you got Yoda up here, too. Is he your mentor?
To many of us, yes, he's one of our mentors. Courtesy of our bookstore, we have these nice Star Wars-themed Cal Poly stickers.
I think it works very well. And is there any other sponsors or advisors you'd like to thank real quick?
Well, we'd like to thank Dr. Edberg, our advisor, and we'd like to thank Rick Maschek, our team mentor. In addition, all of our friends and family for being supportive throughout this pretty rigorous project.
That's right.
Awesome. So why did you guys decide to get involved in this?
Well, actually, Cal Poly has had a NASA student launch team for about 6 years now. We're the 6th year, and we're just kind of continuing the tradition, I was on the team last year, and I was able to get a group of really great students for our team, and we just kind of came together and built the rocket, trying to continue the tradition.
I think you did a pretty good job. You got a good-sized team here. And guys, you should be proud of yourselves for making it this far. We're looking forward to a successful launch. So, folks, this is the Cal Poly team joining us all the way from Pomona, California. Say hi to everybody back home, moms, dads who are watching, grandmas, etc. All right, we're glad you guys could make it. And I guess, are you not going to get on this particular launch set? Or no, this one? Okay, so then we're going to have you step back into the area so you guys can take the next one. Let's bring in our next team. Northwestern, right? Northwestern. I thought so. I recognize what we call you New Stars, but it's NU Stars. What's your first?
Yeah, NU Stars. New Stars.
Cool. All right, from Northwestern University, and another nice-looking rocket, guys. We appreciate it. I like that. Everybody needs to take a little step back because we got to get everybody on the camera there, so moms and dads and grandmas can all see you back home. Okay, so who's going to be doing the talking on this one? Is it going to be you? All right, what's your name?
My name's Carter Robinson. I'm the chief engineer of New Stars, and Northwestern's rocketry team.
All right, and what year are you?
I'm a senior studying mechanical engineering.
So this is it for you?
This is it. This is the last one. It's scary.
Really? You're nervous?
Oh, of course. Oh, why wouldn't I be?
You're not alone. Not just, in your rocket. Believe me, NASA engineers do the same thing. They say they're cool as a cucumber. No, inside the butterflies are flying. So tell us a little bit about your design.
So our rocket here is 110 inches. It's made out of fiberglass. We've got the plastic nose cone. We have the Delta swept back fins right here. It's a hefty one. It's 49.8 pounds. And we're using an L1420 motor from Aerotech. We have 3 parts of our rocket here, of the launch vehicle. The center part with all of those bolts is our payload bay, and that is holding our reaction wheel system. Our payload lead is Evan McConnell right here. I'll let him take over talking about the payload.
You passed the buck, Evan. Pressure's on.
Yeah, so like Carter mentioned, we're using a reaction wheel system, meaning we're using the law of conservation of angular momentum to spin a mass in one direction so that the rest of the vehicle will spin the other way. That's powered by a brushless DC motor, and it's a 2-pound flywheel that spins up to 1,500 RPM to let the rocket spin the other direction.
So that's just basically try to give it a counter spin, right?
Exactly, yeah.
Okay, fantastic. So tell me, guys, why did you decide to get involved in this particular competition?
It's just the unique challenge. We've been doing this competition, I think we've done it 4 times in the last 5 years. Every year it's different, and we love working with all the NASA people and all the other schools.
It's also the people on the team. I've been project manager of these people for the last 8 months, and they're my best friends in the world, and put in a lot of time and effort together, and I'm really proud to be here with them.
I was about to ask, what's it like to try to pull together such a variety of people with disparate views, I'm sure, on a lot of engineering tasks?
Very strange family, but we are a family. But, yeah.
Fantastic. We look forward to seeing it fly here in just a little bit. Once again, the NU stars, new stars, the answer to all of it from Northwestern University. Say hey to everybody back home, guys.
Yes.
Good work. We'll see you here in a little while. All right, we got a lot more launches coming your way here in just a few minutes. Stay with us. You're watching live coverage of NASA's 2017 Student Launch Challenge from Tony, Alabama.
Multi-rotor. There will be a gyro quad in this. There will be two sections at apogee. Both will come under drogue. One at 1,000 feet will deploy an multi-rotor, and the booster at 700 feet will deploy its main parachute. So there'll be two objects in the air. Let's everybody watch this. Pad 61 on an Aerotech L2200 green. On pad 61 in 5, 4, 3, 2, 1, start. Nice straight green boost up. It's arcing over. It's now right above me. We're looking for the event. Event. There's a charge. I see a glint. We have two pieces, both under drogue. The booster is the one that still has the smoke trail on it because it's got the motor. The one that's coming down quicker obviously has the rotor in it. Okay, I'm going to watch the rotor. My spotters are going to watch the booster. It's going through the sun. It's been through the sun. It's about, there we go, 1,000 feet. I see the multi-rotor. They're armed and ready on the multi-rotor. The multi-rotor. Okay, all three pieces. Rotor cannon, and the body booster on its chute. You see it slowly landing in that warm air thermal. Yay! 49er rocketry, UNC Charlotte. T4 heavy on pad 81. Frangible material protection. This has also a vertical landing experiment, a lander. Fragile material protection, integrated dampening capsule. Dual deploy booster, payload on its own chute. Let's watch all the pieces. Pad 81. Going in 5, 4, 3, 2, 1, start. We have an open on the launch commander's console. We're going to move on to the next. Alabama A&M rocket team, pad 40, Cicerone case. 40 is in the first row there. It's the Aurora. It has a roll and a counter roll, and it's going to main at 750. Sky's clear, range is clear. 40 going in 5, 4, 3, 2, 1, start. Nice flight through the sun. It's still climbing. Starting to arc over. There's the charge. We have validation of the drogue. It's about 2,500 feet-ish. Should land right in front of us here to the south. About 1,000 feet, 750 is the main. That's 800. Come on, right about now should be 7. Looking for a backup charge at 5. Come on, backup charge. It's not there. Well, it did. Its trajectory was set so that it would land in the safe landing zone. On pad 51, Lion Tech Rocket Labs, Penn State. It's flying on an L1170. Pad 51 going in 5, 4, 3, 2, 1, start. Arcing over. There's the charge. Confirmation of a drogue. Okay, we're about 900 feet. Looking for a main at 7. Should be now. And you can hear the whoots and hoots from the happy students. Northview Engineering of Sylvania, Ohio. I live in Sylvania, Ohio. Their team's ready on 52. Zapalos Reborn. They have a story on that, on an L800. It has an all-terrain recovery system, inflatable system demonstration. This is going to have a main at 1,000, and apparently it's going to have a terrain recovery system, sort of like some kind of lander. So let's watch this very carefully. 52, Sylvania Northview. And 5, 4, 3, 2, 1, start. Okay, it's heading over the crowd to the flight line. It's arcing over the flight line. It's now to the east of the crowd, but over the flight line. Let's watch this very carefully. It's still coasting upwards. There's the event. We have confirmation that it's together under drogue. It's off to the east, still north of the flight line. So let's everybody watch this carefully. Heads up, everybody, because it's right by the flight line, right by us up here. I want everybody up and looking at this and be able to get up and out of the way. I want you up out of your chairs and be able to move if this comes right to us. It still is north of my table and headed towards me. Again, we're looking for the first. There's the main. There's an inflatable object. Nice black and yellow chute. School colors. And a successful recovery. Awesome! Why are all those kids in those dirt? Let's focus on pad 60, Project ACE. Fragile material payload and parallel spring design. It's going to fly on an L850 White Lightning. It's out on pad 60 going in 5, 4, 3, 2, 1, start. That was a nice motor whistle and roar. Arcing over, L850 White Lightning. Looking for an event. I see a charge, backup charge. I'm now blocked in the sun. Any confirmation on a drogue?
Yes, under drogue.
We have confirmation it's under a drogue. It's well south of the field, and it's on the west side at about 3,700 feet or so. This is 750 Main. Now floating past its own rocket exhaust cloud. Looks like about 28. 22. At about 23. 15. 12. 1,000. 9. 8. 7. There's the main. Awesome flight. We do have aircraft to the south, not the one across the mountain, not the one at 4,800 flight.
This has got a lander.
Oh, this is the one that I was scared to death. This is also the one that has a metal fin can, isn't it? Okay, on pad 62, we have Long Beach, California's Long Beach 49ers. It's Nautilus. This has a paraglider target detection, so it's going to have a lander that's on a paraglider. We're going to have multiple deployments. We have the payload separation at 850 and the main at 800. And L1390 on pad 62. I want everybody looking at all the stuff. A lot of stuff's going to be in the air. Pad 62 going in 5, 4, 3, 2, 1, start. The green motor flame over to the west, south of the flight line so far. It's arcing over. Arcing over. There's an event. There's a second event. We have confirmation it's all tied together on a drogue. Okay, we're running through about 2,700 feet. We're going to have something start here at 800, then another at 7, and another at 650. So this is going to be multiple deployments. It's out in the safe landing zone, so let's watch all the different pieces come out. 1,000 feet, 900, 800 should be about now. Then the next one, and now the next one. There it is. It looks like the paraglider is hung up on the other deployable object, so it's not going to be able to paraglide and detect its target. But going to have a safe landing in that part. The other part's a bit thermal way out in the far zone to the west. Next on pad 80, New Hope from Northwestern University, Boston. It's going to be an L2200 green motor. Recovery in 2 sections, both sections with dual deploy. Very similar to what the gyro system was. This is going to come out at 700 feet on both. So 2 objects at the top and 2 main deploys at 700 feet. Pad 80. L 5, 4, 3, 2, 1, start. A little fishtailing there. Now it's coming over towards the flight line to the west. Everybody watch this. This has a lot of parts coming in. It's arcing over with a charge, a second charge. 2 sections are both under drogue.
Yeah, they may be tied together. I see they're separate. They're separate.
You can see 2 distinct separate items under drogue chute, so we should see 2 distinct deployments at 700 feet. They're coming through about 2,500 now. We're looking for a main at 700 feet. Come on for the next one. Lost the fin can. It's going to be safe out there. Looking for the next one. There's the other main. Nice looking chute. Next, we have the University of Akron. They have a rocket here called the D-Shocker. You might have seen it at the trade show with those giant metal springs holding the air bladders on the inside for protection. Pad 82, L2200. Going in 5, 4, 3, 2, 1, start. Well, the igniter looks like it failed and the motor did not percolate. We're going to recycle some igniters on these rockets before we open the range and try to get them back up again. Okay, thanks to our pad manager, it's got the igniters changed. Thank you, Paul. 49er rocketry, pad 81, fragile material, vertical landing. So it's got two sections at the top. So both have dual deploy, one at 500, one at 500. Pad 81 going in 5, 4, 3, 2, 1. Okay, it is now over the flight line and straight down the road. It's arcing over the crowd, just a little to the west. So let's take a look at this as it comes down because it's going to come back across us. It's arcing over and has an event. We have two objects under drogue have been verified, and they're back of the flight line. They are south of the flight line, so I want people out of their seats. I want them up and looking in the air, and people that can actually see these two objects are going to point at them. They are right now directly across. Okay, this is a heads up. I want everybody looking at this device. It's right to the east of us now, behind the flight line. It is going to come down behind the flight line. The one on top of it's going to come down pretty much a little bit farther south of it. Everybody, heads up. Heads up. Okay, we got another one still left out of there. It looks like it may land in with the cars, the one under chute. I want everybody looking at this. We still have another one coming out that hasn't popped the chute yet, and it's right by near the gator section. It has not popped its main. And there it is. Now, these are going to float into the crowd possibly. I want everybody alert and out of their seats and watching. This one's... It's on a thermal, and it's not knowing where it's going to go, so everybody needs to look at it. Okay, it's going to recover near where the spectators are in the dirt. Do not approach the rocket unless you're the rocket team owner recovery. Do not approach the rocket unless you're the rocket team recovery owner. The Arcanauts rocket design team, the University of Akron with that giant spring with its air sampling, L2200 on pad 82. Sky's clear. It's going in 5, 4, 3, 2, 1, start. There it goes. There it goes. Green motor arcing up a little bit over us. It's arcing over right about over me. We're looking for a charge. Still arcing over, I see a charge event, a second charge event. There is one tiny drogue. This is going to have its main at 850, and it's still up there at about 3,000. And, of course, it'll probably cross the sun in everybody's vision. We're at about 1,500 feet right now, losing it in the sun a little bit. There's 1,000, so it should have a main right about now. Woots and hoots from the Acronauts. Way to go, Acronauts. You can, but not the rest of the crowd. No, only for the bad managers right now. I won't open it with something in there. Something could happen. No, boy, that was a bad call. I know it seems silly, but all viability. It's almost down now. As soon as the rocket's down, we'll have a safe range and open it up for projects. And that should be in 5, 4, 3, 2, 1. Range is open.
Welcome back to our live coverage of NASA's student launch event from Tony, Alabama, just a few short miles from NASA's Marshall Space Flight Center. We've had 50 teams check in. We've got maybe 6 or 7 left to go. They're loading their rockets out on the pads right now, so we thought this would be a good time to catch up with the sponsor of this event, co-sponsor Orbital ATK. Dan Miranda is joining us, and he is the, you have to correct me if I'm wrong on this one, manager of Huntsville operations for Orbital ATK, SLS,
correct.
The SLS program.
SLS program, that's correct.
Okay, thank you very much. Okay, so Dan, I guess you've got to see a lot of the teams here today. What's been most impressive for you?
It's always the excitement of the kids that I find most impressive. Everybody loves rockets; they're really cool. But watching kids and the excitement they bring to a competition like this, there's nothing better.
Why does Orbital ATK decide to throw in on this one and become a sponsor?
Well, there's several reasons. Obviously, we want to support STEM and STEM education. These are the kids that become future rocket scientists and help us, on our journey to Mars. So we definitely want to help grow the next generation of rocket scientists. And, we build a lot of rocket motors. So anything that's smoke and fire, we really like.
So along those lines with the rocket motors, tell us a little bit about what your team does to help out in building the SLS.
Sure. So we are headquartered in Promontory, Utah, and we build the solid rocket boosters for the SLS program. My team here in Huntsville at the Marshall Space Flight Center, we are a liaison office. We have folks that sit on site with the NASA engineering team, working hand in hand to make sure everything goes smooth.
Dan, was there ever anything when we were, I know when I was a kid, maybe not quite something to this effect, but when you were a kid that was like an event like this that got you interested in this?
There was anything this cool. But I do remember we did a Science Olympiad competition, and I was on the Rube Goldberg device. So, I had to make balls roll down hills and trigger switches and flip a mousetrap, and that's what got me into engineering. And once I learned you could light things on fire and launch things into space, I was hooked.
When it comes to, you said with Rube Goldberg, I know you're on a team there. You're, of course, helping manage a major team here. What is it that you think are the kind of things you look for when it comes to assembling a team to help build something as immense as solid rocket?
Oh, absolutely. I think the most important thing for a team is communication, especially in our case where we have a large contingent out in Utah and then another group here. That's 1,700 miles that you got to try to communicate over. So making sure the team's talking and communicating well, and then getting a diverse group together that can bring in a lot of different ideas to let the best ones bubble to the top.
See, and I think these are also all the important things that you just talked about, are the ones that I think a lot of these teams are having to deal with and for this particular challenge.
Oh, absolutely. I've met every kind of engineering major, some English majors. We've kind of covered the gambit today. There are a lot of great kids out here.
Well, we got to last just only a handful more launches to go. So Dan Miranda with Orbital ATK, I appreciate you taking the time to stop by and talk with us. Orbital ATK, of course, the sponsor of the NASA Student Launch Program event here. And once again, we've only got a handful left to go. So let's light some fires here and see a little smoke and fire.
Let's end on a really good note.
Absolutely. All right, we'll be right back with more coverage from Student Launch in Tony, Alabama. Stay with us.
Rocket owners on pad 62. We're trying to find a flight card for that. We don't seem to have been given one. Can you please come up to the LCO with a flight card for the rocket on pad 62? Without the flight card, we won't be able to fly it.
We're joined now by the team from Northview High School in Ohio, and this is a good-sized team and a great-looking rocket. We got Casey and Jenna here who are going to tell us a little bit about what you brought with you today.
Okay, today we brought the all-terrain recovery system. We flew it on a 4-inch diameter rocket, 10 feet tall approximately, and the purpose of the all-terrain recovery system is to inflate a inflatable on the outside of the rocket when it lands. That way it protects it from landing damage, and if it lands in water, it could float.
Sounds cool, actually. Okay, so Jenna, how'd it work?
We believe it worked pretty well. You can tell that it likely inflated due to slight air in the pocket right here.
So the outside here is the inflator you were talking about?
Yeah, so the inflatable is right here.
Oh, very cool. How'd you guys come up with this idea?
It was all thanks to our seniors. They started brainstorming last year and over the summer, and they really worked on some of their preliminary designs, and they got the basis down to use CO2 cartridges and went from there.
So who are the seniors? For show of hands, holy smokes. There's a lot of you. So are you guys all going to perhaps pursue something like this in college? Please say yes.
Yes.
We love to hear that. All right, awesome. So why did you decide to get involved in this challenge?
To be quite honest, my mentor here got me involved. I was helping just another teacher during class, and he was like, hey, do you want to help us with some rockets and do some itineraries for us? And it's just started from there, and it incorporated us more throughout the program, and it's been a really fun time.
And your mentor is?
Ryan Reed.
Okay, Ryan, thanks for helping guide the team. Are there any other mentors, sponsors, or otherwise that you'd like to thank?
Yes, we would like to thank Toledo Jet, Parker Hanovan, Prince Aircraft, Spokes Life, and Materion. As well, again, we would like to thank our mentors, Mr. Reed, Mr. Eckhart, who is somewhere over here, and then Mr. Sharp, because we could not have done this without them giving up their time from their families, and it's been a really good time.
Well, fantastic. Hopefully the seniors will be seeing you on other teams in the future. Hopefully those of you who are not seniors will see you back here next year. Northview High School from Ohio. Say hi to all the friends and family back home, guys.
We did it. No lawn darts.
No lawn darts, right. Awesome. Okay, well, we've got only a few more teams left to launch. We're going to be launching here in just a couple of minutes. Stay with us.
(1,000 feet and also main at 800. Pad 51. Skies clear. Going in 5, 4, 3, 2, 1, start. Just a little tail waggle there. It's going up, 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 up. Still going up. There's a little arc over. Arcing over me. Looking for an event. I see the cloud event. We have confirmation of a drogue chute. The flight card says 3 pieces after drogue. Okay, we have 2 pieces on drogues up there confirmed.
Now the upper piece has a main.
The one piece has a main chute that popped when it shouldn't have, and it's going to float for quite some time. I need a spotter to follow that main. The bottom one's the rocket body. The one with the main is the payload. Should be going at 800 feet. Someone follow the lander while we launch the next one and alert me if there's any safety issues with it. Who's going to follow the lander? Can I get a volunteer to follow the lander?
The lander. We'll make sure we don't launch anything into it.
Okay. Pad 52, New Stars, Northwestern University, Evanston, Illinois. Roll control with a flywheel. That means a real gyro metal. Unless it was 3D printed. Aerotech L1420. Main at 1,000 feet on pad 52. 5, 4, 3, 2, 1, start. It's gone higher than the other one on a parachute. It's still going up. Just about to arc over now. Looking for an event. There's the event. I see a drogue. Can I get someone to spot the next one that's coming down? Do I have a volunteer?
You know, you just launched?
Yes. Can you watch that, Steve? Okay, while we wait for that one to come down with a main at 1,000 feet, we're going to launch the Psi SLI, Iowa State University. Cardinal Heavy is the rocket name on a Cicerone L1500. Main at 800 feet. Pad 60. Pad 60 is going to go in 5, 4, 3, 2, 1, start.
Okay, we just transitioned to main on the last bird.
Okay, the other rocket just popped its main. This one's going up. Still climbing up, 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 up. Still, there it is. Arced over in the charge.
Northwest is just hanging there on it.
Okay, I can confirm a drogue.
Yes, under drogue.
It's on the west side under a drogue. It's floating back towards us.
I know. I'd have to tap the shot.
Psi SLI is about at 2,500 feet, and it's going to deploy at 800. That's about 1,200 right now. We're looking for 800 right about now. It's not good when the microphone actually has a taste there.
You shouldn't lick the microphone.
It jams into my mouth at times. Not licking it. Pad 61, Illinois Space Society, Champlain, Illinois. This vehicle separates into 2 independent sections. One section does not have a drogue on it. So it will come down drogeless. Sky spotters, please note that. This will do a target detection and vertical landing, i.e. a lander, L1390 green, pad 61. It's going to go in 5, 4, 3, 2, 1, start. There it goes up on that green motor. It's still climbing, climbing. Starting to arc over. Looking for an event. There's the event charge. 2 pieces. One is drogeless.
It's supposed to do that. We're just pointing it out.
The one item that's coming down quicker does not have a drogue. In the Midwest, we call that drogeless recovery because we can't find big fields like this to fly in. Makes it come down a little quicker, but it's still safe when it's done in a safe landing area like now, and it should be coming now. Now we got the next one coming. Right about now. And if we notice those special red and white chutes, toroidal design, are really catching the thermals up there and floating on the heat from the fields. Pad 62, Cal Poly, Pomona Rocketry, California. The rocket name is Bat, and it's on an L1420R red line. This has a roll induction system and fragile material. Main at 700. Pad 62, 5, 4, 3, 2, 1. Fire. Nice thunderous roar up there on a red flame, and it's climbing.
Last bird's on the ground.
It's arcing over. Looking for an event. There's the event. Okay, it's still up there at about 4,500. See a small drogue and a sparkling body tube. It's now about 3,500 feet. $700's the main, which should be about now. Nope, a little low. Now. No main. Oh, no joy. It's a soft ground out there. Pad 80. Citrus College Rocket Owls. Glendora, California. L1420 red line. Again, a fragile material protection. Pad 80 going in 5, 4, 3, 2, 1. Awesome roar as it's climbing up. It's doing a little arc over now. Looking for the event. There's an event. We have confirmation of a drogue. It's going to deploy at 800 feet. Oh, I can't hold it. I had a correction. I was told it's going to be at 798.2 feet. Crossing into the sun now. Okay, it's looking about 2,000 feet, 18. About 12 there, 1,000. Looking for 800. Come on, shoot, open, catch the air. There's the backup. No air, didn't catch air. Still a very soft recovery in the safe landing zone. Team Rocket, University of North Texas. ARBOK, Arbok is the name of this rocket with a fragile protection payload. It's on a K-828 Aerotech. Going on pad 81 in 5, 4, 3, 2, 1, start. Smoky motor. A couple fuel grains came out there along with the tracking smoke. There's the event. It's under drogue, and it's all tied together. It's going to have a main deploy at 700. It's about 3,800 feet right now. It's going to drift across the sun and plenty of people's visions. Okay, remember this is going to be at 700 feet, 800, so we should have 7 about now. Come on. There we go. Back up. Caught some air. Multicolor chute rotating on a snap swivel. It does that so it doesn't tangle up the parachute lines. The range will be open. 3, 2, 1 now. It's open.
Okay, well, we have almost all the rockets flown. We've got one last one from the University of California, Berkeley. Congratulations, guys. You're going to be it. You'll be our last one of the day. Okay, first of all, tell us your name and what year you are in school and what your major is.
My name is Avier. I'm a senior at UC Berkeley, mechanical engineering major.
Okay, so Avier is representing all of you. How many seniors do we have here, by the way? 3? Not bad. So that means we assume that all of you are going to come back next year, right? There you go. Okay. So first of all, tell us about your rocket design.
Our rocket is attempted to fly the upright landing payload. So what's unique about this is that we plan to land the entire upper section of the rocket, including the nose cone, which would be deployed, flipped over, and ideally deploying some landing legs. Unfortunately, we won't be flying that right now, but that's the design we've been working on.
So part of the thing that that NASA does on a daily basis is try to mitigate issues and solve problems. What was the problem with yours?
So we've actually definitely had a continuing process of trying to solve problems that sort of arise without us realizing. We've flown this a few times, and each time we've had sort of small electronics failures that really couldn't be foreseen. Today we had a sort of computer failure that occurred on the launch pad, essentially. So this whole semester has been a process of trying to fight fires as they come, while also trying to anticipate them and improve the design for next time.
And hopefully there will be a next time, especially for you seniors. Maybe moving on to the aerospace field. Real quick, is there any kind of sponsors or advisors or folks back home that you want to say hi to?
Definitely. We want to thank all the people at NAR and Dave Ramundi, our team mentor, and we've also got a lot of help from people at our UC Berkeley facilities, at the Mojave Desert Advanced Rocketry Society for helping us launch in a pinch. Definitely a whole bunch of people throughout who have helped us when we needed it most.
All right, well, guys, there's lots of moms and dads watching back home, so wave and say hi to them. This is the team from the University of California, Berkeley, headed out to the launch pad right now. Go, get on there. Hustle. The launch window is closing quickly. So, yeah, they're our last team, so we may stick around for a few more minutes to watch them launch. Stick with us for one last launch. You're watching live coverage of NASA's Student Launch Program.
told me it was gonna be this way. Waking up smiling from the memories we made last night. Can't stop them running through my mind. Hood of my car, sky full of stars, fingers in my jean loops, and my heart in your hand. Felt so right, like it was all in love's plan. So good, so good. Whoa, whoa, better than I ever thought it could. So good, so right, so high. All I want is you again tonight. 'Cause with you I know it would be so good, so good, so good. We could take a little ride across I got a nice, cool, tall boy tasting just right. A moonlit, slow kiss lasting all night. Sipping something strong till we like what we find. So throw up your hands if you like what I like. Throw up your hands if you like what I like. Gotta blow off some steam, gonna have a good time. So throw
All right, welcome back, everyone. We're ready to wrap up another successful day of student launch. Many years we've been accomplishing this great STEM event, and we've got special guests, VIPs, who join us year after year, and one of them is joining us right now. If you would, tell our viewers your name and your role with NASA.
So I'm Diane DeTroy. I'm the Director of STEM Engagement at NASA headquarters, and we support these kinds of activities across the agency because honestly, STEM and developing the next generation workforce through opportunities like this that provide authentic experiences for students is absolutely the way we can grow the next generation.
So have you been to student launch before? Is this your first year?
This is unfortunately my first year, and I have just had a fabulous day. I cannot believe how exciting this has been, and I hope all the viewers that have been watching it have just felt the excitement. It's phenomenal.
So if we look at everything you've seen throughout the day, yesterday and today, what's really just wowed you? Has it been the rockets? Has it been the retrieval systems, the landing systems, talking to the kids at Rocket Fair?
So for me, it was really talking to the students and understanding what they had to do to get here, understanding the whole process that they had to go through. It was wonderful to see the rigor in which they've had to develop everything to get here, and then it's not done once they launch. They've still got more they have to do to close out and make sure they wrap up this experience.
Absolutely. So, and they work really hard, once again, all through the year to get here and accomplish this event. So this is one event of many events. We talked about Human Exploration Rover Challenge, which we had last week, this week's student launch, and that's just here at NASA Marshall. The agency itself across the coast to coast at all multiple centers has lots of different activities. But what are some other things you'd like to talk about and tell our viewers about?
So the Kennedy Space Center runs a robotic mining competition that helps us look at what do we need to do when we get to other planets on mining the systems there. We've got the CubeSat Launch Initiative that allows students to build CubeSats, which are small 10 by 10 centimeters satellites that go, and we launch them into low Earth orbit. We've got a lot of activities for high school students, middle school students that give them an experience that mimics this, and hopefully they'll come to student launch once they get some of those.
Absolutely. And so all those programs across the nation, they're pushing for STEM, science, technology, engineering, and math, getting these kids involved. And as we talk to the kids, we find out they're going and studying mechanical engineering, chemical, whether it's electrical, or even beyond. They're studying degrees. We've talked to finance majors, marketing majors, because these kids design websites and they have to do logistics and fundraising and marketing. So it's not, and that goes back to the idea of what we have at the agency. Yes, a lot of people think that, when you think NASA, you think astronauts.
Right.
And ideally so. But, we get paid every week, but it's not an astronaut that sends me a paycheck.
Right. But it takes everybody to help get those astronauts in orbit. So there's a wealth of people that are on the ground that make it happen, as you say, all the way from the people that are in the technical disciplines to those that are in all of the professional support functions that make turning the crank and helping all that happen.
Absolutely. Yeah. Accounting and medical and legal offices. And so we've got education offices, the computer and as a broadcast communication teams. And so a lot goes into getting everything done across the agency as well as here at Student Launch. So it's wonderful having you join us.
Wonderful to be here. Thank you.
It's been a pleasure. And so we've got one more launch. You can continue to watch this launch on, I think we're going to cut our stream on Facebook Live. You can watch on our NASA Marshall Ustream page as well as on Twitch. And so stay tuned. We got Cal Berkeley is the next and final launch at 2017 Student Launch. So let's see them lift off.
Hotter than South Carolina in July. Got them blue jeans painted on just right. She slid on over, said, baby, put her in drive. And I was like, alright. Got all night to make tonight what we wanted. And it starts with taking a little ride. Following the moonlight, chasing it to the riverside. All night. Think I know where we gotta go for right on the radio. We can roll till tomorrow's sunrise. Just hold on tight. Baby, let's take a ride. I wanna see your hair blowing in the wind
Okay, the range safety officer said we're cleared to go. We're on pad 82. This is KL Star, UC Berkeley, California. It uses a under duress descenders, stratologger, and drogue. We're going to see what it does. It does a main at 1,000 feet and drogue at apogee. Pad 82 on an L1150. Pad 82. 5, 4, 3, 2, 1, start. There's the up part. It's still coasting. The delay train kicked in. You saw the tracking smoke. Arcing over, looking for an event. Looking, there's the first, second charge. There is a drogue, and it's tied together. There's the first part. Cal Star. Drifting around 3,500 each. Berkeley, California. Getting through about 2,800 feet. We got a main at 1,000. About 1,800 about now. Drifting through 1,500. About 12, so we got a 1,000 coming. There it is. Awesome. Beautiful parachute on a beautiful day, closing out the NASA Student Launch Program. Everybody give them a big cheer for the last flight of the night.
And as you heard from Art, that'll wrap it up. That is the last launch of a very long but successful day of launches, Chris.
Absolutely. Nearly 50 launches from teams all around the United States. 23, 24 different teams represented, middle schools, high schools, colleges, universities, from California to Washington all the way to Florida.
Some more successful than others as far as hitting that 1 mile in altitude. But again, sometimes winning the competition is just getting here and getting a chance to test your rockets out here on these pads.
Absolutely. It's the 1 mile marker, as you mentioned, but there are several awards that we're giving out. Actually, once we leave here, we're heading straight to the U.S. Space and Rocket Center for our award dinner and award ceremony, so we can fill our bellies and then we can give out awards, and it wraps up a great day.
And you'll be able to catch those awards on social media, right?
Absolutely. Follow us on, we won't be streaming that on NASA Marshall Ustream or on the Facebook Live, but we will put out the award winners. And so follow us on Twitter at Student Launch. We'll give out all the awards, give you all the winners of who won the best website, best team, best rookie, best spirit award, and all the like. And then the actual winners are announced at a later date.
And hopefully your favorite will be coming home with some hardware. On behalf of Chris Blair, I am Bill Hupsher. Thanks so much for watching us. And on behalf of our entire broadcast crew, thanks for watching the 2017 NASA Student Launch Event. We'll see you next year.